Hari Om. Hello everyone, I am Srijyoti. Welcome back to my channel. Today's video is of class 12 Mathematics CBSE Sample Question Paper 2024-25 questions with detailed solutions. So here you may have seen this question paper. This question paper contains 5 sections A, B, C, D and E. Section A contains 18 questions, that is multiple choice questions of 1 mark each. Now first of all let's go through section A. First question, if for a matrix A into Fj is equal to matrix, square matrix 2025 0 0 0 2025 0 0 0 2025, then the value of determinant of A plus determinant of Fj is equal to dash. These are the options. So here we have an equation A into Fj is equal to determinant A into In. Here In is an identity matrix of order n and given matrix of order 3. So here we can write it is I3. N is equal to 3 here. Okay. And this given matrix can be written as A into Fj is equal to 2025 0 0 0 2025 0 0 0 2025. And we know that the scalar multiplication of matrix, suppose A is a matrix A, B, C, D, okay, then scalar multiplication of matrix, that is K is a scalar, so K into A is equal to Ka, Kb, Kc, Kd, right? So here we can take this 2025 outside from the matrix, so this will be 2025 into 1 0 0 0 1 0 0 0 1, that is 2025 into I3, right? It's an identity matrix of order 3, right? So 2025 into I3. So compare this with this equation, so that we will get determinant of A is equal to 2025, right? Determinant A is equal to 2025. Okay. Then here what is determinant of Fj? Again we have a formula, determinant of Fj is equal to determinant of A raised to n minus 1. If A is of matrix of order n, then it is n minus 1. See here n is 3. Okay, here given matrix is of order 3. Therefore 3 minus 1. Determinant A whole raised to 3 minus 1. That is, what is determinant A? 2025. So 2025 raised to 3 minus 1, that is a square. Okay, so here we have to find the value of this one, that is determinant A plus determinant of Fj is equal to determinant of A is 2025 plus determinant of Fj is equal to 2025 whole square. So D is the answer. Look at the second question. Assume x, y, z, w and p are matrices of order 2 by n, 3 by k, 2 by p, n by 3 and p by k respectively. Then the restriction on n, k and p so that py plus wy will be defined are, these are the options. So here we have to find the values of n, k and p so that this matrix p into y plus y into w into y will be defined. And we know that in matrices, two matrices can be multiplied if number of columns of first matrix is equal to the number of rows of second matrix, right? That is, suppose A is a matrix of order m by n, B is a matrix of order p by q, okay? Then A and B will be defined only if n is equal to p, okay? AB is defined only if n is equal to p. That is, number of columns of first matrix equal to number of rows of second matrix. Okay, then only this AB will be defined. Okay, and what about addition of two matrices? See, two matrices can be added only if they have the same order, right? That is, if A has the order m by n, then B should be has the order m by n, then only this A and B can be added. Okay. So here now let's see. Here we have to find the restriction on n, k and p so that this metric will be defined, right? Okay. So here p, y, w, y. P is a matrix of order p by k, right? And y is a matrix of order 3 by k. And w is a matrix of order n by 3. And y is a matrix of order 3 by k. Okay. Now, what is the multiplication? Here, p into y plus y into w into y, right? So here, what is py? So here, p and y, that is p into y is defined only if k is equal to 3, right? If k is equal to 3, then only py will be defined. Okay. Therefore, here k is equal to 3, and what is the order? P by k. Okay. The order of py is p by k, that is p by 3. Okay. Next here wy, here same order, right? Same order, that is number of columns is equal to number of rows. And what is the order? Order of wy is n by k, right? And so these are the two matrices. So these two can be added only if this should be equal. These two orders should be equal. Okay. That is p by 3 is equal to n by k. That means here p is equal to n and k is equal to 3 is the answer. So if p is equal to n and k is equal to 3, then this py plus wy will be defined. So p is equal to n, k is equal to 3. So A is the answer. The interval in which the function f defined by f of x is equal to e raised to x is strictly increasing is dash. These are the options. We know that e raised to x is a continuous function with domain R and range 0 to infinity, all positive real numbers. Okay. So here given function is f of x is equal to e raised to x. Then what is f dash of x? Derivative of f of x with respect to x is e raised to x itself. It is always greater than 0. That is range of e raised to x is greater than 0. For all x belongs to minus infinity to infinity. If you substitute any negative values, this e raised to x is always greater than 0. Okay. Therefore, here we have studied that in functions, if f dash of x is greater than 0 for all x belongs to minus infinity to infinity, then given function, that is e raised to x, f of x is equal to e raised to x, is strictly increasing on minus infinity to infinity. Okay. So it is the answer. If A and B are non-singular matrices of same order with the determinant of A is equal to 5, then determinant of B inverse A B whole square is equal to dash. Here it is given that A and B are non-singular matrices, that is determinant of A and determinant of B are not equal to 0. Okay. Then it is given determinant of A is equal to 5. We have to find determinant of B inverse A B whole square, that is determinant of B inverse A B whole square, that is equal to determinant of B inverse into determinant of A into determinant of B whole square, right? And here we know that determinant of B inverse into determinant of B is 1, right? That is determinant of I, that is 1. Okay. So 1 into determinant A whole square, that is equal to determinant of A whole square. That is determinant of A, it is given determinant of A is equal to 5. Therefore it is 5 square. So 5 square is the answer. the value of n such that the differential equation x raised to n dy by dx is equal to y into log y minus log x plus 1, where xy belongs to R plus is homogeneous is, that is value of n is dash. So these are the options, and here we studied that if dy by dx can be expressed as a function of y by x, then this differential equation is a homogeneous differential equation, right? That is dy by dx, it is the function of y by x. Okay, if dy by dx can be expressed as a function of y by x, then this differential equation is a homogeneous differential equation. Now let's take this given differential equation, x raised to n dy by dx is equal to y into log y minus log x plus 1. This can be written as dy by dx is equal to, take this x raised to n here, so y divided by x raised to n, and this can be written as log y minus log x, that is log of y divided by x plus 1, this can be written as log e. Okay, that is dy by dx is equal to y divided by x raised to n log x plus log y, that is log x into y, right? So here this can be written as log e into y by x. Okay. Now here see, if n is equal to 1, then this will be a function of y by x, right? Therefore, then only we can say this differential equation is a homogeneous differential equation, right? So here for the value of n is equal to 1, this given differential equation is a homogeneous differential equation. Therefore, n is equal to 1. If the points x1, y1, x2, y2 and x1 plus x2, y1 plus y2 are collinear, then x1, y2 is equal to dash. In determinant chapter, we have studied that if 3 points are collinear, then determinant of, suppose x1, y1, x2, y2 and x3, y3 are collinear, then determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1 is equal to 0. Okay, that is if 3 points x1, y1, x2, y2 and x3, y3 are collinear, these 3 points are collinear means these 3 points lie on the same line, right? So if these 3 points are collinear, then determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1 is equal to 0. So here given that 3 points x1, y1, x2, y2 and third point is x1 plus x2, y1 plus y2. These points are collinear. Okay, that is determinant of x1, y1, 1, x2, y2, 1, x3, here x1 plus x2, y1 plus y2, 1. That is equal to 0. Now this let's expand this determinant. x1 into y2 minus of y1 plus y2, that is minus y1 minus y2, minus y1 into, remove this, so x2 minus of x1 plus x2, that is x2 minus x1 minus x2, okay, plus 1 into, here delete this row and column, so x2 into y1 plus y2 minus y2 into x1 plus x2, that is equal to 0. Simplify this one. See here y2 minus y2 cancelled, x2 minus x2 cancelled, then here minus x1 y1, here minus into minus plus x1 y1, okay, plus x2 y1 plus x2 y2 minus x1 y2 minus x2 y2, that is equal to 0. Now here minus x1 y1 plus x1 y1 cancelled. After that minus x1 y2, minus x2 y2 plus x2 y2 cancelled. Okay, so remaining x2 y1 minus x1 y2 is equal to 0. This implies x2 y1 is equal to x1 y2. So here x1 y2 is equal to x2 y1. A is the answer. If A is equal to matrix 0, 1, C minus 1, A minus B, 2, 3, 0 is a skew symmetric matrix, then the value of A plus B plus C is dash. Here we studied that a matrix A is said to be skew symmetric matrix if A is equal to minus A transpose. If it is a symmetric matrix, then A is equal to A transpose, right? If it is skew symmetric matrix, if a matrix is said to be skew symmetric matrix, then A is equal to minus A transpose. Okay, if A is equal to minus A transpose, then A is a skew symmetric matrix. So here given matrix is 0, 1, C minus 1, A minus B, 2, 3, 0. So here A is equal to minus A transpose. That implies here matrix A is equal to 0, 1, C minus A minus 1, A minus B, 2, 3, 0. And what is A transpose? It's a transpose is that is changing rows to column, right? So here and minus of. So here 0, okay, minus into minus plus 1 minus 2. Next here minus 1 minus A minus 3 minus C B 0. It is minus A transpose. Okay. So here equate this. If two matrices are equal means their corresponding elements are equal, right? So here C is equal to minus 2. This implies C is equal to minus 2 and A is equal to minus A and minus B is equal to minus 3. That implies here A is equal to minus A means A plus A is equal to 0. That is 2A is equal to 0. That implies A is equal to 0. So here we have got A is equal to 0, B is equal to 3 and C is equal to minus 2. Therefore, A plus B plus C is equal to 0 plus 3 plus minus 2, that is 1. So the value is 1. For any two events A and B, if probability of A complement is equal to 1 by 2, probability of B complement is equal to 2 by 3 and probability of A intersection B is equal to 1 by 4 and probability of A complement divided by B complement, A complement given B complement, okay, equals, these are the options. So here we have to find probability of A complement given B complement. We studied that probability of A given B, that is equal to probability of A intersection B divided by probability of B, right? Here probability of A complement given B complement, that is equal to probability of A complement intersection B complement divided by probability of B complement, okay? And here this can be written as we have studied in sets, right? That is A complement intersection B complement, that is equal to A union B whole complement, right? That is, so here this can be written as probability of A union B whole complement divided by probability of B complement. That is, we know that probability of A complement is nothing but 1 minus probability of A, right? Because probability of A plus probability of A complement, that is equal to 1, right? So probability of A complement is equal to 1 minus probability of A. So this can be written as, it is 1 minus probability of A union B and here 1 minus probability of B. Now we need to find probability of A union B. Probability of B is given, probability of A union B, and it is given that probability of A intersection B. Okay, so here how to find probability of A union B? Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. We have this formula, right? So here substitute probability of A is See, probability of A complement is given. Then what is probability of A? 1 minus 1 by 2, right? Because probability of A plus probability of A complement is equal to 1. Therefore, probability of A is 1 minus probability of A complement. So, probability of A is equal to 1 minus 1 by 2, that is 1 by 2. 1 by 2 plus here probability of B complement is equal to 2 by 3. Then what is probability of B? 1 minus probability of B complement, that is 1 minus 2 by 3, that is 1 by 3, right? So 1 by 3 minus probability of A intersection B is 1 by 4. So 12 is the LCM. So here 6 plus 4 minus 3 divided by 12, that is 6 plus 4 10, 10 minus 3 7, 7 by 12. So probability of A union B is equal to 7 by 12. Now let's substitute this one here, that is probability of A complement given B complement is equal to 1 minus 7 by 12 divided by, here no need to write 1 minus probability of B because it is directly given probability of B complement, right? So directly we can substitute, that is probability of B complement. Okay, probability of B complement is 2 by 3. That is equal to 12 minus 7, 5 by 12 divided by 2 by 3, that is 3 by into 3 by 2. So that is 3 ones are 3 fours are. So 5 divided by 8 is the answer. Yes, C is the answer. The value of alpha if the angle between vector P is equal to 2 alpha square I minus 3 alpha j plus k and vector Q is equal to I plus j plus alpha k is obtuse angle is, then what is the value of lambda? Okay, value of lambda is, these are the options. See here it is given that angle between these two vectors is an obtuse angle. And here we know that what is the formula, that is cos theta. We have studied that cos theta is equal to vector P or vector B1 dot vector B2 divided by modulus of vector B1 into modulus of vector B2. That is the formula, right? Here we know that cosine of an obtuse angle is negative. Okay, an obtuse angle means angle greater than 90 degree, right? So cos of, that is cos of an obtuse angle is negative. So here we know that cos theta is equal to vector P dot vector Q divided by modulus of vector P into modulus of vector Q, right? These are modulus, right? So here cos theta for obtuse angle, here it is given that if this theta is obtuse angle, then what is the value of lambda, right? So here we have to find the value of lambda. So for obtuse angle, cos theta is less than 0. Okay, because we know that cosine of an obtuse angle is always negative. Okay, so here cos theta is less than 0. That implies this vector P dot vector Q is less than 0. Because this one is always positive. Okay, so therefore vector P dot vector Q is less than 0. Okay, for cos theta less than 0. Okay, why cos theta less than 0? Because theta is an obtuse angle. And we know that cosine of an obtuse angle is negative. Okay. So here P dot Q less than 0. So what is P dot Q? 2 alpha square into 1 plus minus 3 alpha into 1 plus 1 into alpha is equal to 2 alpha square minus 3 alpha plus alpha. That is, so P dot Q less than 0 implies this one less than 0, right? That is 2 alpha square minus 3 alpha plus alpha minus 2 alpha less than 0. That implies 2 alpha is common. So 2 alpha into alpha minus 1 less than 0. See, this implies either 2 alpha less than 0, either 2 alpha less than 0 or alpha minus 1 less than 0, right? And here, if 2 alpha less than 0, then alpha minus 1 greater than 0, right? Because it is totally less than 0, that means either 2 alpha less than 0 or alpha minus 1 less than 0, right? That is, if 2 alpha less than 0, okay, that implies, if 2 alpha less than 0, then alpha minus 1 greater than 0, right? 2 alpha less than 0 means alpha less than 0. Here alpha greater than 1. That means alpha, the value of alpha is between 0 to 1. Right? That is, this can be written as, see here, 0 greater than alpha greater than 1. That is, alpha is between 0 and 1. And another case, if alpha minus 1 less than 0, if alpha minus 1 less than 0, 2 alpha greater than 0. Right? For this negative value. Okay? So, if alpha minus 1 less than 0 means alpha less than 1. If alpha minus 1 less than 0, 2 alpha greater than 0. That is, alpha less than 1 and alpha greater than 0. This here also we can write 0 less than alpha less than 1. So here also, in this case also, the value of alpha is between 0 and 1. So it is the correct answer. Okay, the value of alpha is upper interval 0 to 1. If modulus of vector A is equal to 3 and modulus of vector B is equal to 4 and modulus of vector A plus vector B is equal to 5, then modulus of vector A minus vector B equals. So here modulus of, we know that modulus of vector A plus vector B square is equal to modulus of vector A square plus modulus of vector B square plus 2 into vector A dot vector B. Right? And similarly, modulus of vector A minus vector B square is equal to modulus of vector A square plus modulus of vector B square minus 2 into vector A dot vector B. So add these two equations so that this will be cancelled, right? So here we will get modulus of vector A plus vector B square plus modulus of vector A minus vector B square is equal to vector A, that is modulus of vector A square plus modulus of vector A square, that is 2 into modulus of vector A square plus 2 into modulus of vector B square. So take 2 outside. So modulus of vector A square plus modulus of vector B square. That is, here substitute what are given. Modulus of vector A plus vector B is given, that is 5. So its square is 25 plus modulus of vector A minus vector B, this one we have to find, that is equal to 2 into modulus of A square is 9, modulus of B square is 16, that is equal to 2 into 25, that is 50. Right? So here take this 25 here. So modulus of vector A minus vector B is equal to 50 minus 25, that is 25. Therefore square, okay, it is square. So therefore modulus of vector A minus vector B is equal to square root of 25, 5. Okay, minus 5 is not possible, it is modulus value. Okay, therefore plus 5. So therefore modulus of vector A minus vector B is 5. For the linear programming problem, the objective function is z is equal to 4x plus 3y and the feasible region determined by a set of constraints is shown in the graph. Which of the following statement is true? See here, options are about the value of the function at these points. Okay. So here let's find the value of the function at these corner points. What are the corner points we have? 0, 40, 30, 20, 40, 0. Right. So let's find the value of the functions at this point. Okay. That is z, value of the function is objective function. Objective function is z is equal to 4x plus 3y. Z is equal to 4x plus 3y. Next, first corner point. Okay. Let's consider 0, 40. So corner point 0, 40. What is the value of the function? Substitute x is equal to 0. Y is equal to 40. So it will be z is equal to 120. Right? And at the point 30, 20, value of z is equal to, substitute x is equal to 30, that is 120. 120 plus 60, 180. Okay. Next, at the point it is 40, 0. corner point 40, 0, z is equal to put x is equal to 40, so 160, 160, 0, so 160. Okay, now let's go through the options what are given. Maximum value of z is at r of 40, 0. It's wrong, right? Because we have got this function, that is z is maximum at 30, 20. Okay, at the point 30, 20. So maximum value of z is at 30, 20. That is true, right? Value of z at r of 40, 0 is less than the value of at p of 0, 40. See, 40, 0, that is 160. It is greater than 0, 40, right? So this sentence is wrong. So next is the value of z at q of 30, 20 is less than the value at r of 40, 0. This is also false, right? So the correct statement is maximum value of z is at 30, 20. Integral of dx divided by x cube into 1 plus x raised to 4 whole raised to 1 by 2 equal to dash. So here, see, here direction substitution is not possible, right? Because see, if you put 1 plus x raised to 4 is equal to t, we will get dx as, that is dt as 4x cube, right? 4x cube. But here x cube in the denominator, so we cannot substitute, right? So first of all, here rewrite this integrand as integral dx divided by x cube into 1 plus x raised to 4 whole raised to 1 by 2, that is equal to integral. See, here let's take this x raised to 4 outside, okay, outside of this bracket. See, this bracket is nothing but it is the whole raised to 1 by 2, means square root, right? So here let's take x square outside, sorry, x raised to 4 outside, okay. So x raised to 4 into 1 plus 1 by x raised to 4 whole raised to 1 by 2, right? Now here, see, x raised to 4 whole raised to 1 by 2 is nothing but x square. That is square root of x raised to 4, that is x square, right? So here integral dx divided by, taking x square here, okay, so it will be x raised to 3 into x square, that is x raised to 5, okay, it will become x raised to 5, okay. Now here 1 plus 1 by x raised to 4 raised to 1 by 2. See, now it become, see, 1 plus x raised to minus 4. Now we can put t is equal to 1 plus x raised to minus 4, because when we take its derivative, that is, it will be x raised to minus 5, right? So here put t is equal to 1 plus 1 by x raised to 4, that is nothing but x raised to minus 4, right? So x raised to minus 4. So dt is equal to, derivative of 1 is 0. So minus 4 into, derivative of x raised to minus 4 is minus 4 into x raised to minus 4 minus 1, that is minus 5. Right? Now here, see, what is x raised to minus 5 dx, right? X raised to minus 5 dx is minus 1 by 4 dt. Right? X raised to minus 5 dx. We have x raised to minus 5 dx, right? Because see, 1 by x raised to 5 is nothing but x raised to minus 5. So x raised to minus 5 dx. We have x raised to minus 5 dx. So we can substitute x raised to minus 5 dx as minus 1 by 4 dt. Right? So substitute. So this integrand is equal to integral dx by x raised to minus 5. See, 1 by x raised to 5 is nothing but x raised to minus 5. So x raised to minus 5 dx is minus 1 by 4 dt divided by, now it is nothing but t raised to 1 by 2, because we have substituted 1 plus 1 by x raised to 4, that is 1 plus x raised to minus 4 as t, right? So t raised to 1 by 2, that is t raised to 1 by 2 means root t. Okay, then so it is minus 1 by 4 dt divided by root t, that is equal to, we know that integral of 1 by root t is root t. 1 by 2 root t, right? 1 by 2 root t is root t, because derivative of 2 root t, that is root t is nothing but 1 by 2 root t, right? So here 1 by 2 root t is, its integration is root t. Okay. So here it will be minus 1 by 2 root t. Okay. Because see, integral of 1 by 2 root x is equal to root x. Okay. Because derivative of d by dx of root x is nothing but 1 by 2 root x. Right? Derivative of root x is 1 by 2 root x. Therefore, integral of 1 by 2 root x is root x. Okay. So, here minus 1 by 2 into 1 by root t. 2 root t. Right? So, its integral is minus 1 by 2 root t plus c. Okay. That is minus 1 by 2 root t. What is t? We have put t is equal to 1 plus x raised to minus 4, that is 1 by x raised to 4 raised to 1 by 2 plus c. Okay. That is, see here, take LCM. So it will be minus 1 by 2 into x raised to 4 plus 1, that is 1 plus x raised to 4 divided by x raised to 4 whole raised to 1 by 2 plus c. That is equal to minus 1 by 2. Here when we take this x raised to 4 outside, that is, before that we have to take the square root, right? Because it is whole raised to 1 by 2. So x raised to 4 whole raised to 1 by 2 means x raised to 2, x square, right? So 1 by 2 x square, 1 plus x raised to 4 whole raised to 1 by 2, or we can write square root. Okay, because answer is in square root. Okay, square root of 1 plus x raised to 4 plus c. So the answer is minus 1 by 2x square root of 1 plus x raised to 4 plus c. So correct answer is A. Integral 0 to 2 pi cosec raised to 7x dx equal to dash. Here we have a property, integral 0 to 2a f of x is equal to 0 if f of 2a minus x is equal to minus f of x. Okay. If f of 2a minus x is equal to minus f of x, then the integral 0 to 2a f of x is equal to 0. Now let's take. Here f of x is nothing but cosec raised to, f of x is equal to cosec raised to 7x. Right? Now what is f of 2a? What is 2a here? 2 pi. Right? So 2 pi minus x. What is f of 2 pi minus x? F of x is equal to this one. F of 2 pi minus x is cosec raised to 7 2 pi minus x. Now what is cosec of 2 pi minus x? What is the value? That is cosec of 2 pi minus x. See, cosec here, cosec of 2 pi minus x. See, this cosec in fourth quadrant, right? 2 pi minus x means it lies in fourth quadrant, right? In fourth quadrant, cosec is negative. Cosec is positive in first and second quadrant, right? Cosec is the reciprocal of sine, right? So here sine is negative in fourth quadrant. That is, so here cosec also negative in fourth quadrant. So therefore cosec of 2 pi minus x is minus cosec x. Since it is 2 pi, cosec itself. Okay, and cosec of 2 pi minus x is minus cosec x, because 2 pi minus x it lies in fourth quadrant. 2 pi minus, 2 pi plus means first quadrant, 2 pi minus fourth quadrant. Okay, so here it is minus cosec x. Okay, and what about cosec raised to 7 2 pi minus x, that is minus cosec x whole raised to 7, right? So minus 1 raised to 7 is nothing but minus 1 itself, since it is odd. Right? So minus cosec raised to 7x. Right? Cosec raised to 7x. That is equal to, now it is minus cosec raised to 7x is nothing but f of x. Right? So minus f of x. See, we have got f of 2 pi minus x is equal to minus f of x. So according to this property, here its answer is 0. That is integral of 0 to 2 pi cosec raised to 7x dx equal to 0. Correct answer is A. the general solution of the differential equation, e raised to y dash is equal to x. E raised to y dash means dy by dx, derivative of y with respect to x. So here we have to find the general solution of the given differential equation. So given differential equation is e raised to y dash, that is e raised to dy by dx is equal to x. Okay, and we have a logarithmic property. If e raised to y is equal to x, then y is equal to log x, right? We have already studied. E raised to y is equal to x, then y is equal to log x. So this can be written as dy by dx is equal to log x, right? Then take this dx here, dy is equal to log x dx. Now x and y terms are separated, right? So by variable separable method, we can find the solution. Integrating on both sides, integral dy is equal to integral of log x dx. Integral of dy is nothing but y, right? And what is integral of log x? See, if you don't know the integral of log x, you just find by integration by parts. That is, integral of log x dx is equal to integral log x can be written as log x into 1 dx, right? So here consider log x as the first function and 1 as the second function. Okay, so here log x into integral of second function, that is x, minus integral of derivative of log x, derivative of first function, that is 1 by x, and integral of the second function x dx, that is x into log x minus integral of 1 by x, x cancelled, so 1 dx, integral of 1 with respect to x is x plus c. Okay, so integral of log x is x log x minus x plus c. Okay, so here x log x minus x plus c. See, y is equal to x log x minus x plus c. So B is the correct answer. The graph drawn depicts y is equal to sin inverse x, y is equal to cos inverse x, y is equal to cosec inverse x, y is equal to cot inverse x. Okay, so here it's a graph of inverse function. Now here it is x-axis and y-axis. Okay, so first of all let's write f inverse of, only 2 points are mentioned in x-axis, right? So f inverse of 0, what is f inverse of 0? Pi by 2. Right? It is the point 0 pi by 2. It is the point 1 0. Right? So what is f inverse of 1? F inverse of 1 is 0. Right? So from the graph we have written this. Next, flip this x-axis and y-axis here so that we will get f of pi by 2 is equal to 0. F inverse of 0 is equal to pi by 2 implies f of pi by 2 is equal to 0. Right? And f of 0 is equal to 1. Okay. Now, which trigonometric function satisfies this condition? That is, f of pi by 2 is equal to 0. We know that cos pi by 2 is equal to 0, right? And cos 0 is equal to 1, right? So here f of x is cos x. But here it is the given graph is the inverse function, right? So inverse trigonometric function. Here we can write cos inverse of pi by 2, that is cos inverse of 0. So cos inverse of 0 is equal to pi by 2. Cos inverse of 1 is equal to 0. Right? Cos inverse of 0 is equal to pi by 2. So cos inverse of 1 is equal to 0. Therefore, cos inverse function satisfying this. Right? Therefore, this graph is of y is equal to cos inverse x. So correct answer is B. A linear programming problem along with the graph of its constraints is below. The corresponding objective function is z is equal to 18x plus tan y, which has to be minimized. The smallest value of the objective function z is 134 and is obtained at the corner point 38. The optimal solution of the above linear programming problem. These are the options. First option, does not exist as the feasible region is unbounded. See here, given linear programming problem is about find the minimum value of the function. Okay, minimum at which point the function that is objective function is minimum, right? So and it is given that the smallest value of this objective function is 134 at the point 38, right? So here solution exists. Okay, so this statement is false. And second, does not exist as the inequality 18x plus 10y less than 134 does not have any point in common with the feasible region. So this option, this statement is also about the solution does not exist. But here solution exists, right? So third one, exists as the inequality 18x plus 10y greater than 134 has infinitely many points in common with the feasible region. It's wrong, right? So here 18x plus 10y greater than 134. See, it is the line that is 18x plus 10y is equal to 134 and it has that is greater than 134 means this side, right? Towards this side. So here there are many points. There is no common point, right? So there is no common point in the feasible region. So here this statement is also false. And here the fourth one, exists as the inequality 18x plus 10y less than 134 does not have any point in common with the feasible region. This statement is correct, right? Because see, it is the line 18x plus 10y is equal to 134. It is less than 134 means towards the origin, right? So here we have to, it is given that the objective function which has to be minimized, right? So minimum value of the function, right? So here this side there is no common point in the feasible region. So what is the minimum value? That is nothing but minimum value is 134 and at the point 38. Okay, so the solution is 38. At the point 38, the minimum value of the function is 134. So this statement is correct. That is, exists, solution exists as the inequality 18x plus 10y less than 134. Okay, that is this side. There is no common point in the feasible region. Therefore, the minimum value of the function is 134 at the point 38. Okay. A function f from r to z defined by f of x is equal to greatest integer of x, and this function is continuous at x is equal to 2.5 but not differentiable at x is equal to 2.5. Not continuous at x is equal to 2.5 but differentiable at x is equal to 2.5. Not continuous at x is equal to 2.5 and not differentiable at x is equal to 2.5. Continuous as well as differentiable at x is equal to 2.5. See here, we know that greatest integer function is not continuous at any value of integral values. Okay, if x is equal to, if x are integers, then this function greatest integer function is not continuous. Okay, we have already proved in differentiability, continuity and differentiability chapter, right? So here, so remember this function greatest integer function is not continuous at any value of any integral value of x. If x is integer, then this function is not continuous. Otherwise, it is continuous. Okay, here x is equal to 2.5. 2.5 is not an integer, therefore this function is continuous. Okay, so this function is continuous at x is equal to 2.5. And similarly, differentiability. In differentiable also, this function is not differentiable at any value of integral values of x. Okay, but otherwise it is differentiable. Okay, therefore here x is equal to 2.5. Okay, it is given that x is equal to 2.5. It's not an integer. Therefore, this function is continuous at x is equal to 2.5. Okay, this function is continuous as well as differentiable. Okay, at x is equal to 2.5. Therefore, B is the correct answer. Okay. A student observes an open-air honeybee nest on the branch of a tree whose plane figure is parabolic shape given by x square is equal to 4y. Then the area of the region bounded by parabola x square is equal to 4y and the line y is equal to 4 is dash. See here, it's very simple question. We have to find the area between the curve and the line. Curve is x square is equal to 4y and the line y is equal to 4. Okay, this figure is not given. So the curve is x square is equal to 4y, that is parabola towards y axis, right? So it is the curve parabola x square is equal to 4y and the line y is equal to 4. So we have to find the area between the curve and the line, that is this region, shaded region. Okay, area of the shaded region. So it is enough to find the area of this one part, then multiply by 2 to get the total area, right? So here what is the area of this region? So total area, that is required area is equal to 2 into area of this region, right? That is area of this region. See here we are taking the points of on the y-axis, right? So here that integrating with respect to y. Okay, therefore we should integrate with respect to y. Therefore integral 0 to 4, these points are on the y-axis. Okay, so 0 to 4 x dy. Okay, x with respect to y, that is equal to 2 into integral 0 to 4. What is x? X square is equal to 4y. Therefore x is equal to root 4y, that is 2 root y dy. That is equal to 4 into, take this 2 outside, 4 into integral 0 to 4, integrate root y with respect to y. Root y is nothing but y raised to 1 by 2. Integral of y raised to 1 by 2 is y raised to 3 by 2, that is 1 by 2 plus 1 divided by 1 by 2 plus 1 divided by 3 by 2. Limits 0 to 4. Okay. Now substitute upper limit then lower limit. Okay. That is 4 into, here 3 by 2, so it will become 8 by 3. Right. This 2 will be in numerator, that is 8 by 3. Substitute y is equal to 4 raised to 3 by 2 and minus 0. That is equal to 8 by 3 into 4 raised to 3 by 2. 4 raised to 1 by 2 is 2. 2 cube is 8. That is 64 divided by 3 square units. So the required area is equal to 64 divided by 3 square units. Therefore B is the correct answer. Next question is assertion reason based questions. Here 19th and 20th questions are assertion reason based questions carrying 1 mark each. So 19th question, here given assertion is, consider the function defined as f of x is equal to modulus x plus modulus x minus 1. X belongs to R. Then f of x is not differentiable at x is equal to 0 and x is equal to 1. In continuity and differentiability we have studied that if left hand derivative is equal to right hand derivative at a point, then the function is differentiable at that point, right? So here let's check whether this function is differentiable or not differentiable at x is equal to 0 and x is equal to 1. Okay, so first of all the given function is f of x is equal to modulus x plus modulus x minus 1, right? So here first of all left hand derivative, that is f dash of 0. So first of all let's take the point x is equal to 0. Okay, so f dash of 0, that is equal to limit h tends to 0 minus f of 0 minus h minus f of 0 divided by minus h, right? That is equal to, here f of 0 minus h. What is f of x? Modulus x plus modulus x minus 1. F of 0 minus h is modulus 0 minus h plus modulus 0 minus h minus 1, right? X is equal to 0 minus h. Okay, substitute x is equal to 0 minus h minus f of 0. F of 0 is modulus 0, that is 0, plus modulus 0 minus 1, that is modulus minus 1, that is 1, right? So divided by minus h, that is equal to, see modulus of minus h is h. Here modulus of minus, take minus outside, so it will be modulus of plus modulus of h plus 1, minus of h plus 1, that is h plus 1, right? Minus 1 divided by minus h. Here 1 minus 1 cancelled, 2h divided by minus h, that is equal to minus 2. Now next we will find right hand derivative. Okay, that is at the point x is equal to 0, limit h tends to 0 plus f of 0 minus h minus f of 0 divided by, not minus h, plus h, right? That is equal to, here f of 0 minus h, substitute x is equal to 0 minus h. So modulus 0 minus h plus 0 minus h modulus 0 minus h minus 1. F of 0 is nothing but modulus of minus 1, that is 1, divided by h. So here also we will get 2h divided by h, that is equal to 2. See, here we have got left hand derivative is not equal to right hand derivative. Left hand derivative is minus 2, right hand derivative is 2, right? So here we can say this function f of x is equal to modulus x plus modulus x minus 1 is not differentiable at x is equal to 0. Okay. Similarly, we can prove it is not differentiable at x is equal to 1. Therefore, this given assertion is true. Okay. Now let's go to the reason. See here, this reason says that suppose f be defined and continuous on open interval ab and c belongs to ab, then f of x is not differentiable at x is equal to c if limit extends to c minus f of c plus h minus f of c divided by h is not equal to limit extends to c plus f of c plus h minus f of c divided by h. See here, this reason describing the differentiability test, right? See, we know that if it is left hand derivative is not equal to right hand derivative, right? So, if left hand derivative is not equal to right hand derivative, then this function is not differentiable at x is equal to c. So, this reason is true, right? And here, this reason is the correct explanation of assertion, right? So, the correct answer is A, because both A and R are true, that is both assertion and reason are true and R is the correct explanation of assertion, right? Next question, given assertion is the function f from R minus 2n plus 1 pi by 2 such that n belongs to z, 2 minus infinity to minus 1 union 1 to infinity defined by f of x is equal to sec x is not one function in its domain. Here given function is f of x is equal to sec x. So what is one function? See, we know that one function if f of x1 is equal to f of x2 implies x1 is equal to x2, then function is one function. That is, images of different elements are distinct, right? See, for example, here it is set x, set y and function f from x to y. Okay, the elements 1, 2, 3 are the elements of domain and a, b, c are the elements of codomain. So here 1 to a, 2 to b and 3 to b. See this function. This function is not one function because here see b has more than 2 pre-images, right? So here that is images of different elements are distinct. Okay, f of x1 is equal to f of x2 implies x1 is equal to x2. Then the function is 1. Suppose 3 to c, now here see images of different elements are distinct, right? So here function f is one function. Okay, now we have to check this one function f of x is equal to sec x is not one function or not. See here for that, see we know that sec pi by 3, that is sec 60 is equal to 2, right? See why we are taking 2? See the reason. Line y is equal to 2. So now let's check. Take 2, okay, from the codomain, okay. So here this 2 belongs to this codomain, right? Yes. So here we know that sec of 60, that is cos of reciprocal of sec is nothing but reciprocal of cos, right? So sec 60, that is 1 by cos 60. Cos 60 is 1 by 2, therefore sec pi by 3, that is 1 by cos pi by 3, that is 2. 1 by 1 by 2, that is 2, right? Now what about sec of minus pi by 3? We know that cos of minus theta is equal to cos theta. Therefore sec of minus theta is equal to sec theta, right? So sec of minus pi by 3, that is equal to sec of pi by 3. That is also 2. Now what about, see, what is sec of 5 pi by 3? See here, we know that cos and sec are positive in the fourth quadrant. Now it is 2 pi, right? So it lies in the fourth quadrant. 2 pi, cos and sec are positive in the fourth quadrant. So here we can write, see, sec pi by 3, or let's take cos, okay? So cos pi by 3, that is equal to cos of 2 pi minus pi by 3. Why? Because cos of 2 pi, if it is 2 pi, cos itself, okay? And minus pi by 3, it lies in fourth quadrant, right? In fourth quadrant, these are positive. So here we can write cos pi by 3 is equal to cos 2 pi minus 3. 2 pi minus pi by 3. That is cos of 5 pi by 3, right? So here we can write sec of 5 pi by 3, that is equal to sec of pi by 3, that is also 2. And sec of minus 5 pi by 3, that is also 2. Because sec of minus theta is sec theta, right? So here, see, it is clear that the element 2, that is element of codomain, this 2 has more than one preimages, right? So 2 has, see, pi by 3 is also, pi by 3 is a preimage of 2 and minus pi by 3, 5 pi by 3 and minus 5 pi by 3, these are the preimages of 2. Therefore, we can say that this function f of x is equal to sec x is not one function in its domain, right? Because these all are belongs to in this domain, okay? So next is, therefore, this assertion is true, okay? This function is not one function because element 2 in the codomain has more than one preimages. That is, sec x is equal to 2, sec x is equal to 2 is true for more than one value of x. Okay, so therefore this function f of x is equal to sec x is not one function. And next is, so it is, this assertion is true. Okay, next reason, the line y is equal to 2 meets the graph of the function at more than one point. See here, we know that y is equal to 2, that means sec x is equal to 2. Okay, y is equal to 2, that means, see, y is nothing but here an element of codomain, right? So this y is equal to 2 means sec x is equal to 2. And here we know that in this function sec x is equal to 2 is true for more than one value of x. That means this y is equal to, line y is equal to meets the graph of the function at more than one point. Therefore, this function is not one function, right? So see here, this statement is correct, right? The line y is equal to 2 meets the graph of the function at more than one point. We know that, right? See here, suppose it is x-axis and y-axis, y is equal to 2 means it is this line. So this y is equal to 2 meets the more than one point of x, right? All the points of x, right? So here this statement is true and also this statement is the correct explanation of this assertion, right? Because here y is equal to 2 means sec x is equal to 2. Okay, here but the function is f of x is equal to sec x, that is y is equal to sec x. So y is equal to 2 means sec x is equal to 2. So sec x is equal to 2 is true for more than one value of x, right? Therefore, it is the correct explanation of this assertion. So the correct answer is A. Both A and, that is both assertion and reason are true and R is the correct explanation of assertion. Look at the next question. If cot inverse of 3x plus 5 greater than pi by 4, then find the range of the values of x. Okay. If cot inverse of 3x plus 5 greater than pi by 4, then we have to find the values of x. That is from where to where. Okay. So here, this can be written as cot inverse of 3x plus 5 greater than pi by 4. This pi by 4 can be written as cot inverse of 1, right? Because cot pi by 4 is 1, right? Cot pi by 4 is 1. Therefore, 1 is equal to cot inverse pi by 4, right? Sorry, pi by 4 is equal to cot inverse of 1. That is, cot pi by 4 is equal to 1, right? Therefore, pi by 4 is equal to cot inverse of 1, right? So here this pi by 4 can be written as cot inverse of 1. So now we have got the inequality cot inverse of 3x plus 5 greater than cot inverse 1. We have to find the values of x, right? Okay. And here, see, we know that cot inverse x, cot inverse function is decreasing function. Why? Because see derivative, what is derivative of cot inverse x? That is minus 1 by 1 plus x square. See, it is less than 0 for all x. Right? For any values of x, it is less than 0. That means here f dash of x, see, suppose if f of x is equal to cot inverse x, then f dash of x is less than 0. We have studied in increasing and decreasing function, right? If f dash of x is less than 0, then the f of x is decreasing function, right? Decreasing function. Therefore, here cot inverse x is decreasing function. And also we know that, see, if f of x1 greater than f of x2, when x1 greater than x2, then we say that this function f of x is an increasing function, right? Or if f of x1 less than f of x2, when x1 greater than x2, then f of x is decreasing function, right? So here cot inverse x is decreasing function, okay? Therefore, see, this one can be written as it is 3x plus 5 less than 1, right? Because cot inverse of 3x plus 5 greater than cot inverse 1, okay? It is cot inverse x is decreasing function. Therefore, these values, that is, will change the inequality. That is 3x plus 5 less than 1. See here, f of x1 less than f of x2, or we can write, see, f of x2 greater than f of x1. Rewriting this one, when x1 greater than x2. See, f of x2 greater than f of x1, when x1 greater than x2. Okay. So here cot inverse of 3x plus 5 greater than cot inverse 1. Since cot inverse x is decreasing function, okay, 3x plus 5 less than 1. Okay, that means x is 3x less than 1 minus 5, that is minus 4. So x less than minus 4 by 3. That implies, see, x less than minus 4 by 3. That implies x belongs to minus infinity to minus 4 by 3. So, it is the range of the value of x. Next, 22nd question. See here, 21st to 25th questions are very short answer type questions carrying 2 marks each, and these questions are in section B. Okay. So 22nd question, the cost in rupees of producing x items in factory. Okay. So number of items is x. Producing x items in factory. Each day is given by C of x is equal to 0.0013 x cube plus 0.002 x square plus 5x plus 2200. Find the marginal cost when 150 items are produced. See here, in applications of derivatives, we have already studied that marginal cost is nothing but rate of change of cost function. That is, derivative of cost function is the marginal cost, right? So here that is marginal cost. We have to find a marginal cost, right? So marginal cost is derivative of C of x. That is derivative of C of x with respect to x. Okay, that is equal to C of x is this one. So what is C dash of x? That is 3 into this one, right? Into x square. 0.00039, right? Into x square plus 0.002 into 2, 4x plus 5. Derivative of 5x with respect to x is 5. And derivative of constant is 0. It is C dash of x. Here we have to find marginal cost. It is the marginal cost. Okay. Marginal cost when 150 items are produced. Okay. Here number of items produced is x. Right. So when 150 items are produced, then what is the marginal cost? That means C dash of x when x is equal to 150. Okay. So here C dash 150. C dash of 150 we have to find. Okay. That is, substitute x is equal to 150. 0.0039 into 150 square. 15 square is 225, right? So 22500. 150 square is 225 into 100, right? plus 0.004 into 150 plus 5. Okay. Now let's find 39 into 225. 225 into 39. 9 5s are 45. 4. 9 2s are 18. 18 4 22. 9 2s are 18. 20. 3 5s are 15. 3 2s are 6. 7. 3 2s are 6. 5 7 7 8. So here if it is 22500, then 1 2 3 5 places, right? So 5 places. Now it is nothing but 8.775 plus it is 4 into 150 is 15 into 4 is 60, so 600. So 3 places are decimal, right? So here it will be 0.6 plus 5, that is equal to, it is 9.375 plus 5, that is 14.375. So it is marginal cost, right? Therefore marginal cost is equal to rupees 14.375. Twenty-third question or question is there. So first question, find the derivative of tan inverse x with respect to log x. Here let y is equal to tan inverse x and z is equal to log x. Okay. See here we have to find the derivative of tan inverse x with respect to log x, right? That is derivative of y with respect to z. We have to find dy by dz, right? So let's find dy by dx, that is derivative of y with respect to x. So what is derivative of tan inverse x with respect to x? 1 by 1 plus x square, right? And what is dz by dx? Derivative of log x with respect to x is 1 by x, right? Now dy by, we have to find dy by dz, right? Derivative of tan inverse x with respect to log x, that is equal to, that is dy by dz is equal to dy by dx divided by dz by dx, right? That is equal to dy by dx is 1 by 1 plus x square divided by dz by dx is 1 by x, that is equal to x divided by 1 by 1 plus x square. Twenty-third question B. Differentiate the following function with respect to x. Given function is cos x whole raised to x. So how to differentiate such a function? So take y is equal to cos x whole raised to x, right? Taking logarithm on both sides, log y is equal to x log cos x, right? X log cos x, that is log of cos x whole raised to x is x log cos x, right? Now differentiate it with respect to x on both sides. So here it will be log y, derivative of log y is 1 by y into derivative of y dy by dx, right? That is equal to, here x into log cos x. X is the first function, log cos x is the second function. So first function x into derivative of log cos x, derivative of log x is 1 by x, right? Therefore derivative of log cos x is 1 by cos x into derivative of cos x is minus sin x, plus second function into derivative of first function, that is log cos x into derivative of first function, derivative of x is 1. So it is equal to minus sin x by cos x, tan x, minus tan x, right? So minus x tan x plus log cos x. Now take this y right side. So dy by, we have to find a dy by dx, right? So dy by dx is equal to y into log cos x minus x tan x. Now let's substitute what is y. Y is nothing but cos x whole raised to x, right? So cos x whole raised to x into log cos x minus x tan x. It is the answer. Next question. if vectors vector A is equal to 2i plus 2j plus 3k, vector B is equal to minus I plus 2j plus k, C is equal to 3i plus j are such that vector B plus lambda vector C is perpendicular to vector A, then find the value of lambda. We know that if two vectors are perpendicular, then their dot product is 0, right? So here it is given vector B plus lambda vector C and vector A are perpendicular, therefore their dot product is 0. So first of all we have to find what is vector B plus lambda vector C. Vector B plus lambda vector C is equal to, vector B is minus I plus 2j plus k plus lambda C, that is lambda into 3i plus j, right? That is equal to minus 1 plus 3 lambda minus 1 plus 3 lambda I plus 2 plus lambda j plus k, right? It is lambda vector B plus lambda vector C, and it is given that this vector and vector A are perpendicular. Therefore, their dot product is 0. That is vector A dot vector B plus lambda vector C is equal to 0. Right? So, what is vector A dot vector B? So, here that is vector A is 2i plus 2j plus 3k dot minus 1 plus 3 lambda I plus 2 plus lambda j plus k is equal to 0. That is 2 into minus 1 plus 3 lambda plus 2 into dot product definition, 2 into 2 plus lambda plus 3 into 1, 3, that is equal to 0. Simplify this one. Minus 2 plus 6 lambda plus 4 plus 2 lambda plus 3 is equal to 0. That is minus 2 plus 3 is 1, 1 plus 4, 5. So 8 lambda is equal to minus 5. That implies lambda is equal to minus 5 by 8. Next question, 24th or question. A person standing at the origin is watching an aeroplane which is at the coordinate point A of 403. At the same time, he saw a bird at the coordinate point B of 001. Find the angles which vector BA makes with the x, y and z axis. See, here we have to find the angle between this vector and x, angle between this vector and y, angle between this vector and z, right? So, easiest way to find the angle between two vectors is applying the formula cos theta is equal to, that is dot product, A vector A dot vector B divided by modulus of vector A into modulus of vector B, right? So, here see, first of all let's find what is vector BA. Vector BA, that is vector OA minus vector OB, right? That is vector OA, that is position vector of A is 4i plus 0j plus 3k, right? And minus vector OB 0i plus 0j plus k, right? That is equal to 4i plus 2k. It is vector B. Okay. Now we have to find angle between vector BA and x, that is x-axis. So the x-axis means here what is the vector? Unit vector. Okay, on x-axis unit vector. So here we have to find vector BA with x-axis, that is vector BA and x-axis. So here let's take vector BA as vector A. Okay, vector A is equal to 4i plus 2k. Next, we have to find here, first of all, let's find the angle between vector BA and x-axis, right? Okay, so here next vector B is equal to, that is unit vector on x-axis. So it is nothing but vector I, that is I cap. Here j component and z component are 0, right? So I cap. Okay. Next, so here we have to find the angle between these two vectors, right? So here cos theta is equal to vector A dot vector B divided by modulus of vector A into modulus of vector B, right? That is equal to vector A dot vector B is 4 into 1, 4 plus J is 0 here, so no J, and 2 into here K is 0, K component is 0, therefore 0, divided by modulus of vector A is 4 square 16, 16 plus 2 square 4, so 16 plus 4 20, so square root of 20, right? And modulus of vector B is 1, right? See here modulus of vector A is root of 4 square plus 2 square, that is root of 20. Modulus of vector B is, that is modulus of 1 square, that is 1. Okay. Now here it is 4 by root 20, that is 4 divided by root 20 can be written as 2 root 5. 20 is 4 into 5, so 2 root 5. That is equal to 2 cancelled, so 2 by root 5. Therefore here theta is equal to cos inverse of 2 by root 5. Okay. So here it is nothing but it is angle between this vector BA and x-axis. Okay, so vector BA, here we have taken vector BA as vector A. Okay, so it is the angle between vector BA and x-axis. Next we will find angle between vector BA and y-axis. Okay, so here vector A and here vector B is that is on y-axis, right? Unit vector, that is vector J. Okay, J cap. Okay, vector B is J cap. Now here cos theta is equal to vector A dot vector B divided by modulus of vector A into modulus of vector B. Okay, if you are confusing, you just take vector C. Okay, this vector as vector C. So here it is vector A dot vector B. So 4 into 0, 0. So 2 here 0, right? J is also 0, and K 2 into K component 0. Therefore, here numerator it is 0 divided by root 20 into 1, that is 0, right? So, cos theta is equal to 0, that implies theta is equal to pi by 2, right? Pi by 2, because cos pi by 2 is 0. Here it is the angle between this vector and y-axis. Okay. Next is, let's find this vector, angle between this vector and z-axis. So here vector A is the same thing, that is 4i plus 2k, that is nothing but vector BA. Okay. And here we will take vector B as, that is vector of unit vector of vector z-axis, right? So here that is k cap, because here component I component and j component are 0. Okay. So here what is cos theta? Cos theta is equal to vector A dot vector B divided by modulus of vector A into modulus of vector B. That is equal to, see 4 into 0, here I component is 0, so 4 into 0, 0, and j component is 0 here, and k component 2 into 1, 2. So 2 divided by root 20 and modulus of vector B is 1. That is equal to 2 divided by root 20 can be written as 2 root 5. 2 cancelled. So 1 by root 5. Now cos theta is equal to 1 by root 5. Theta is equal to cos inverse 1 by root 5. Okay, therefore angles which makes, that is which vector BA makes with the x, y and z axis are cos inverse of 2 by root 5, pi by 2 and cos inverse of 1 by root 5 respectively. Okay, that is angles which vector BA makes with the xy and z axis are cos inverse 2 root 5, 2 by root 5, pi by 2 and cos inverse 1 by root 5 respectively. 25th question. The two co-initial adjacent sides of a parallelogram are 2i minus 4j minus 5k and 2i plus 2j plus 3k. Find its diagonals and use them to find the area of parallelogram. Here two adjacent sides of a parallelogram are given. We have to find the diagonals, two diagonals, and find the area of the parallelogram. We know that if we have two diagonals of a parallelogram, then find the area of the parallelogram. We have a formula, right? So here first of all let's take vector A is equal to 2i minus 4j minus 5k and vector B is equal to 2i plus 2j plus 3k, right? Now suppose it is the parallelogram, okay? So here two diagonals. Suppose it is vector A, it is vector A in this direction and it is vector B, okay? Now by triangular law of vector addition, this diagonal is nothing but vector A plus vector B, okay? And see, it is vector B, so this vector, that is opposite direction, so it is minus vector B, okay? It is minus vector B and it is vector A. So again by triangular law of vector addition, see it is minus vector B, it is vector A and this diagonal is nothing but vector B minus vector B plus vector A, that is vector A minus vector B. So here two diagonals, let two diagonals be vector D1 and vector D2. So vector D1 is equal to vector A plus vector B, okay, and another vector D2 is equal to vector A minus vector B. So vector A plus vector B add corresponding components, 2 plus 2 4, 4i minus 2j minus 2k. And vector D2 is equal to vector A minus vector B is equal to, subtract 2 minus 2 0, so I component 0, minus 2 minus 4 minus 2 minus 6j minus 8k, okay. Now we have got two diagonals and how to find the area of parallelogram. We know the formula, area is equal to 1 by 2 into modulus vector D1 cross vector D2. Okay, so here first of all let's find vector D1 cross vector D2, that is cross product of two vectors by determinant. Okay, so D1 vector D1 cross vector D2 is equal to determinant I, j, k. So components of D1 4 minus 2 minus 2, 0 minus 6 minus 8, that is equal to I into here minus, that is 16 minus 12 minus j into minus 32 minus 0 plus k into minus 24 minus 0, that is equal to 4i plus 32j minus 24k. Here 4 is common, take 4 outside, so 4 into I plus 8j minus 6k. Okay. Now let's find modulus of vector D1 cross vector D2. Modulus of vector D1 cross vector D2, that is square root of 4 square 16 into 1 plus 64 plus minus 6 square 36, that is equal to, here 16 take it from the square root, so it will be 4. So 4 into root of 65 plus 36, 101. Okay. So here area is equal to 1 by 2 into 4 into square root of 101, that is equal to 2 root 101 square units. Next, section C. This section contains 6 questions of short answer type questions carrying 3 marks each. 26th question. A kite is flying at a height of 3 meters and 5 meters of string is out. If the kite is moving away horizontally at the rate of 200 centimeter per second, find the rate at which the string is being released. Okay, so what is given? A kite is flying at a height of 3 meter from the ground. Okay. So it is 3 meter and see kite is here, okay, and it is given 5 meters of string is out. So it is the string. So it is the ground AB. See, and it is given that this kite is moving away horizontally at the rate of 200 centimeter per second. Okay. Now let this distance be x meter and this distance be y meter. Okay. So here say it is given this kite is moving away horizontally at the rate of 200 centimeter per second. That is, this kite is moving horizontally, right? So here we know that, see, when the string is being released, the distance of this x is increasing. X will be increasing, right? So when the string is being released, because this kite is moving horizontally, right? So this distance will be increasing, right? So here, what is that dx by dt? Dx by dt, that is rate of change of this distance x. That is nothing but 200 centimeter per second, right? Because it is given this kite is moving away horizontally at the rate of 200 centimeter per second. So dx by dt is equal to 200 centimeter per second. Okay. Now we will get an equation, that is by Pythagoras theorem. Here we can write x square plus 3 square, that is x square plus 9 is equal to y square, right? Differentiate it with respect to x. 2x dx by dt is equal to 2y dy by dt. Okay. Now let's find when y is equal to 5 meter, what is the length of x? Okay. When y is equal to 5, when y is equal to 5 meter, say this measurement is in centimeter, so let's make it convert it into centimeter. Okay, so here y is equal to 500 centimeter. Okay, then what is x? Okay, if it is in 5 meter, then what is x? X is equal to 4 meter, right? So here let's substitute x and y values here in centimeter. Okay, so 2 cancelled. Substitute x, what is dx by dt? Substitute it. So x is equal to 400 into dx by dt 200 is equal to y is, what is y? 500 into dy by dt. What we have to find? We have to find dy by dt, that is rate of change of string, right? So here that implies 2 zeros cancelled. So 800 divided by 500, that is equal to dy by dt, right? That implies dy by dt is equal to, sorry, it is cancelled. Okay, so 5 1s are 60. Okay, so 160 centimeter per second. So it is the rate at which the string is being released. Okay, that is dy by dt, that is equal to 160 centimeter per second. 27th question. According to a psychologist, the ability of a person to understand spatial concepts is given by A is equal to 1 by 3 root t, where t is the age in years and t belongs to 5 to 18. Okay. Show that the rate of increase of the ability to understand spatial concepts decreases with age in between 5 and 18. See here, we have to show that the rate of increase of the ability to understand spatial concepts decreases in the age between 5 and 18. Okay. So that is, we have to show the rate of increase of the ability decreasing, okay, is decreasing in the interval 5 to 18, right? We have to show the rate of increase of the ability is decreasing in the interval 5 to 18, right? So here, that is, we have to show R is, what is our rate of increase of the ability, okay? So R is decreasing in the interval 5 to 18, okay? And here in applications of derivatives, we have studied that increasing and decreasing function, right? So if f dash of x is less than 0, then we say f of x is decreasing, right? So here we have to prove R is decreasing, okay? That means here we have to show r dash is less than 0. Okay, if r dash is less than 0, then we can say r is decreasing, right? So here we have to show r dash is less than 0 in the interval 5 to 18. Okay, that is, what is r? R is nothing but rate of increase of the ability. That is, R is equal to rate of increase of ability. That is, here it is given that the ability of a person understand spatial concepts is given by A. A is equal to 1 by 3 root t. So here rate of increase of the ability is dA by dt. Right? That is, here what is A? A is equal to 1 by 3 root t. That implies dA by dt is equal to 1 by 3 into 1 by 2 root t. So, okay, 1 by 2 root t. That is equal to 1 by 6 root t. Okay, it is R. Next we have to find R dash. That is d square A by dt square. That is derivative of dA by dt with respect to t. So we have to differentiate it again with respect to t. Okay. So here R dash is equal to d square A by dt square. That is equal to, find the derivative of this one, 1 by 6 into 1 by root t, that is nothing but t raised to minus 1 by 2, right? So derivative of t raised to minus 1 by 2, that is equal to minus 1 by 2 into 1 by 6, t raised to minus 1 by 2 minus 1, that is minus 3 by 2. That is minus 1 by 12, t raised to minus 3 by 2. See here, if you substitute t is equal to any value between 5 and 80, you will get this minus, right? That is minus. That means r dash is less than 0. So it is less than 0 in the interval 5 to 80. Right? That means here rate of increase of the ability is decreasing because we have got r dash is less than 0. If f dash of x is less than 0, then f of x is decreasing, right? So here we have got r dash is less than 0 in the interval 5 to 18. Therefore, r is decreasing in the interval 5 to 18. What is r? R is the rate of increase of the ability. Okay, therefore, rate of increase of the ability is decreasing in the interval 5 to 18. Okay, in the age in between 5 and 18. Question. 28th question is OR question. Okay, so 28th A. An ant is moving along the vector L1 is equal to I minus 2j plus 3k. Few sugar crystals are kept along the vector L2 3i minus 2j plus k, which is inclined at an angle theta with the vector L1. Okay. So then find the angle theta, also find the scalar projection of vector L1 on vector L2. Very simple, right? So here first of all we have to find the angle between vector L1 and vector L2. Okay? And after that projection of vector L1 on vector L2. We have formulas, right? So first of all here we have to find cos theta, right? So we have a formula, cos theta is equal to vector L1 dot vector L2 divided by modulus of vector L1 into modulus of vector L2. It is the formula to find the angle between two vectors, right? So here vector L1 dot vector L2, vector L1 is I minus 2j plus 3k dot 3i minus 2j plus k divided by square root of modulus of vector L1, that is square root of 1 square 1 plus minus 2 square 4 plus 3 square 9 into square root of modulus of vector L2 is square root of 3 square 9 minus 2 square plus 4 plus 1, that is equal to 1 into 3, dot product of two vectors, 1 into 3, 3, minus 2 into minus 2, plus 4, 3 into 1, plus 3, divided by, it is square root of 14, right? 14, square root of 14. That is equal to 10 divided by square root of 14 into square root of 14, 14, right? That is 5 by 7. Okay. So cos theta is equal to 5 by 7. We need to find theta, that is angle between L1 and L2. So theta is equal to cos inverse of 5 by 7. So the angle between vector L1 and vector L2 is cos inverse 5 by 7. Next we have to find scalar projection of vector L1 on vector L2. So projection, we have a formula, projection of vector L1 on vector L2 is equal to vector L1 dot vector L2 divided by on L2, right? So divided by modulus of vector L2. See, vector L1 dot vector L2 we have already found, that is 10, right? Vector L1 dot vector L2 is 10. So 10 divided by modulus of vector L2 is square root of 14, right? Okay. So here it is the projection of vector L1 on vector L2 here. Next question, 28th B. Find the vector and the Cartesian equation of the line that passes through the point minus 1, 2, 7, 2, 7 and is perpendicular to the lines vector r is equal to 2i plus j minus 3k plus lambda into i plus 2j plus 5k and vector r is equal to 3i plus 3j minus 7k plus mu into 3i minus 2j plus 5k. Here we have learned that vector equation of a line passing through a point with the position vector vector A and parallel vector vector B is vector r is equal to vector A plus lambda vector B, right? That is vector equation of a line passing through a point with the position vector vector A and parallel vector vector B is vector r is equal to vector A plus lambda vector B, right? We have learned that. So here vector we can find vector A directly, right? Because it is given that line is passing through the point minus 1, 2, 7. So vector A is nothing but minus I plus 2j plus 7k, right? And what is vector B? It is a parallel vector. Okay, the required vector is parallel to vector B. But here it is given that the required vector is perpendicular to these two lines. Okay, perpendicular to these two lines. Therefore, here the vector B is perpendicular to these two lines. That is 2i plus j minus 3k plus lambda into I plus 2j plus 5k. And this vector B is perpendicular to, because vector B is parallel to required line, right? So vector B is perpendicular to these two lines, okay? And 3i plus 3j minus 7k plus mu into 3i minus 2j plus 5k, right? So here vector B is perpendicular to these two lines. And we know that this line is perpendicular to, that is parallel to this line, right? Parallel to this line is parallel to this vector, right? Therefore, here vector B is perpendicular to I plus 2j plus 5k and 3i minus 2j plus 5k. Vector B is perpendicular to these two vectors, okay? Therefore, here we can say vector B is the cross product of these two vectors. We know that here vector A cross vector B, then vector A cross vector B is perpendicular to vector A and vector B, right? In cross product we have learned that vector A cross vector B is perpendicular to both vector A and vector B. See here vector B is perpendicular to both of these vectors. Why? This vector B is perpendicular to both of these lines, right? And this line is parallel to this line, this vector, and this line is parallel to this vector. Therefore, this vector B is perpendicular to these two vectors. Therefore, here we can say vector B is the cross product of these two vectors, right? That is, vector B is equal to cross product of these two vectors, that is determinant I, J, K, 1, 2, 5, 3, minus 2, 5. Okay, vector B is cross product of these two vectors. Because if vector A cross vector B is perpendicular to both vector A and vector B. Okay. So here let's find I into 10 plus 10 minus J into 5 minus 15 plus K into minus 2 minus 6. Minus 2 minus 6. That is 20I minus 10J minus 8K. So take 2 outside. So 2 into 10I minus 5J minus 4K. Okay. So here it is the vector B. Okay. So we can write it as, see this one, vector, what is our required line? That is vector R is equal to vector A plus lambda vector B. So here vector R is equal to, that is required line, vector R is equal to, vector A is minus I plus 2J plus 7K plus 2 into lambda, okay, 2 lambda into vector B 10I minus 5J minus 4K. So it is the required line. Okay, here we can write 2 lambda as mu. Okay, so after that, see, it is the vector equation of the required line. Okay, and next we have to write Cartesian equation. So just convert it into Cartesian equation. How? That is Cartesian equation x minus minus 1. Okay, so x plus 1 divided by 10 is equal to y minus plus 2. That is y minus 2 divided by minus 5 is equal to next z minus 7 divided by minus 4. So it is the Cartesian equation of required line. Twenty-nine has also OR question. So 29th A, evaluate integral of 1 by log x minus 1 by log x whole square dx where x greater than 1. So how to integrate? See, integral of 1 by log x, this can be written as integral of 1 by log x dx minus integral of 1 by log x whole square dx. Right? So now here first of all we will integrate it this one by using integration by parts. Okay. So here we can write 1 by log x into 1. Okay. Then integral 1 by log x into 1 dx. Okay. Minus integral of 1 by log x whole square dx. Now what is the integral of this one? Using by integration by parts. So here let's consider 1 by log x as the first function. That is 1 by log x into integral of 1 dx, okay, minus integral of derivative of 1 by log x, d by dx of 1 by log x, okay, into integral of 1 dx dx minus this second integral of 1 by log x whole square dx. Okay. Now that is here integral of 1 dx is nothing but x. So x by log x minus integral of derivative of 1 by log x. See, what is the derivative of 1 by x? D by dx of 1 by x is minus 1 by x square, right? So d by dx of 1 by log x is minus 1 by log x whole square into derivative of log x, that is 1 by x. Right? So here derivative of 1 by log x is minus 1 by log x whole square into 1 by x. So this minus minus become plus. Okay? Into x. Okay? Minus integral of into x dx is here. Okay? Integral of 1 by log x whole square dx. See, now this x cancelled. Now it is become x divided by log x plus integral of 1 by log x whole square plus c is here. Okay? Whole square dx minus integral of 1 by log x whole square dx plus c. See, these two integrals cancelled. Okay. Now the answer is x divided by log x plus c is the answer. Twenty-ninth B. Evaluate integral 0 to 1 x into 1 minus x whole raised to n dx. We have already done this one, right? So here we have a property in integration. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Right? So let's apply this property here. That is integral 0 to 1 x into 1 minus x whole raised to n dx is equal to integral 0 to 1. Here x minus, a minus x, right? Here a is equal to 1. Okay. So in place of x, we should write 1 minus x. Okay. Into 1 minus x, right? Dx. That is equal to whole raised to n. Okay. So it is 1 integral 0 to 1. 1 minus x into 1 minus 1 cancelled. Minus minus become plus. So it is x raised to n dx. That is equal to integral 0 to 1 x raised to n into 1 x raised to n minus x raised to n plus 1 dx. Right? Now integrate it. Very simple, right? So integral 0 to 1 x raised to n is x raised to n plus 1 divided by n plus 1. Limit is 0 to 1 minus integral of x raised to n plus 1 is x raised to n plus 2 divided by n plus 2. Limit is 0 to 1. Substitute the limits. First upper limit. So x is equal to 1. 1 raised to n plus 1 is 1. So 1 by n plus 1 minus. When we substitute x is equal to 0, it will be 0, right? Okay. So minus. Here substitute x is equal to 1. So 1 by n plus 2, that is equal to, take LCM. So n plus 2 minus n plus 1, n minus n cancelled, 2 minus 1, 1. So 1 by n plus 1 into n plus 2. Thirtieth question. Consider the following linear programming problem. Minimize z is equal to x plus 2y. Subject to 2x plus y greater than or equal to 3, x plus 2y greater than or equal to 6, xy greater than or equal to 0. Show graphically the minimum of z occurs at more than 2 points. This question we have already done, right? So here, first of all we have to draw the graph, right? So to draw the graph we have to find the values of x and y. For that, let's take the equation 2x plus y is equal to 3 and x plus 2y is equal to 6. So when x is equal to 0, y is equal to 3. When y is equal to 0, x is equal to 3 by 2. Here, when x is equal to 0, y is equal to 3. When y is equal to 0, x is equal to 6. Right? Now plot the points. 0, 3, 0, 3, it is the point 0, 3. And 3 by 2, 0. When x is equal to 3 by 2, y is equal to 0. So it is the point 3 by 2, 0. Join these points. So this line is 2x plus y is equal to 3. And next 0, 3, it is the point 0, 3. And 6, 0, it is the point 6, 0. Join these points. So this is the line x plus 2y is equal to 6. Okay. So after that, find the feasible region. Okay. So here y greater than or equal to 3. The inequalities, it is greater than or equal to 3. So the feasible region is towards this side. Okay. Now, next is to x plus 2y greater than or equal to 6. X plus 2y greater than or equal to 6. So here also the feasible region towards this side. Okay. So here common region is this one, right? Okay. And see, it is clear that this feasible region is not bounded. It is unbounded, right? And the minimum, so next we will find the minimum value of z. Okay, at which point? So what are the corner points? 2 points are there, right? That is 0, 3 and 6, 0 are the corner points, right? So here let's find the minimum value of z. Z is equal to x plus 2y. Okay. So what are the corner points? 0, 3 and 6, 0. At 0, 3, what is the value of z? Z is equal to, substitute x is equal to 0, y is equal to 3. So z is equal to 6. Here z is equal to 6 plus 0, 6. Okay. So here we have got the minimum value of z is 6. Okay. At the corner points 0, 3 and 6, 0. So here, see, it is the line, right? So this line joining the points 0, 3 and 6, 0. So here it is clear that this minimum value of z is 6, right? Minimum value of z is 6 at the points on the line. Okay. So here our feasible region is from this. Okay. Here it is unbounded and the minimum value of z is 6 at the points on the line joining the points 0, 3 and 6, 0. Okay. So there are many points on the line, right? So here there are many points, that is this problem has the minimum value of z is 6 and it occurs at more than 2 points. Because here the minimum value of z is 6 at the points, that is at the points on the line segment joining the points 0, 3 and 6, 0. Okay. So here we can say minimum value of z is 6 at the points on the line segment joining the points 0, 3 and 6, 0, right? There are many points on the line, right? So here we can say this problem has the minimum value of z is 6 and it occurs at more than 2 points. Okay. Question 31st A, there are 2 questions or questions are there. So the probability that it rains today is 0.4. If it rains today, the probability that it will rain tomorrow is 0.8. If it does not rain today, the probability that it will rain tomorrow is 0.7. If P1 denotes the probability that it does not rain today, P2 denotes the probability that it will not rain tomorrow if it rains today, P3 denotes the probability that it will rain tomorrow if it does not rain today, P4 denotes the probability that it will not rain tomorrow if it does not rain today. So here first of all let's find the values of this probability. Okay. So here what is P1? Now here question is find the value of P1 into P4 minus P2 into P3. For that we have to find the values of these probabilities, right? So here first of all P1. What is P1? Value of P1. See, P1 is nothing but it denotes the probability that it does not rain today. And it is given the probability that it rains today is 0.4. So it is nothing but complement of this one, right? So that is 1 minus 0.4, right? Because P1 is the probability that it does not rain today. It is the complement of it rains today, right? So here 1 minus 0.4. P1 is equal to 0.6. Next, P2 denotes the probability that it will not rain tomorrow if it rains today. It is given that if it rains today, the probability that it will rain tomorrow is 0.8. So it is the complement, right? It will not rain tomorrow if it rains today, right? So here it is the complement of this one, right? So here also P2 is equal to 1 minus 0.8, that is 0.2. Okay. Next, P3. What is value of P3? P3 is equal to, P3 denotes the probability that it will rain tomorrow if it does not rain today. And it is given that if it does not rain today, the probability that it will rain tomorrow is 0.7. So it is also the complement of it will rain tomorrow, right? So it is the complement, P3 is the complement of this 0.7, right? So P3 is equal to 1 minus 0.7, that is 0.3. Okay. Next is P4 denotes the probability that it will not rain tomorrow if it does not rain today. See, that is, if it does not rain today, the probability that it will rain tomorrow is 0.7. Yes, P3 is, see P3, sorry, I did the mistake. P3 denotes the probability that it will rain tomorrow. Okay, it will rain tomorrow if it does not rain today. So the same thing, it is given, right? If it does not rain today, the probability that it will rain tomorrow is 0.7. So P3 is equal to 0.7. Okay. Next, P4 is, P4 denotes the probability that it will not rain tomorrow if it does not rain today. So it is the complement of this statement, right? That is, if it does not rain today, the probability that it will rain tomorrow is 0.7, right? So P4 is 1 minus 0.7, that is 0.3. Okay, now find the answer for first question. Find the value of P1 into P4 minus P2 into P3, that is equal to, P1 is 0.6 into P4 0.3 minus P2 0.2 into P3 0.7, that is equal to, it is 0.18 minus 0.14, that is equal to 0.04. Next, second question, calculate the probability of raining tomorrow. Next, second question, calculate the probability of raining tomorrow. See, there are two cases for it will rain tomorrow, right? That is, if it rains today and if does not rain today, right? So here, let's take two events, E1 be the event, it rains today, okay? E1 be the event, it rains today. And E2 be the event, it does not rain today, okay? And what we have to find? Probability of raining tomorrow, right? That is probability of it will rain tomorrow. So let A be the event, it will rain tomorrow, or raining tomorrow, okay? Now what we have to find? We have to find probability of A. So here we will apply total probability theorem, okay? That is, so for that we have to find probability of A given E1, right? A given E1, that is probability of it will rain tomorrow given that, say, it rains today has already occurred, okay? So here it is given, if it rains today, the probability that it will rain tomorrow is 0.8. So probability of A given E1 is nothing but 0.8, right? And probability of E2, probability of A given E2 that is equal to, that is probability of it will rain tomorrow, and it is given that it does not rain today. Okay, so here it is given if it does not rain, the probability that it will rain tomorrow is 0.7. So probability of A given E2 is nothing but 0.7. Now what is probability of E1? Probability of E1, it rains today. Probability of it rains today is 0.4, right? And probability of E2, E2 is the event it does not rain today, right? That is, it is the complement of it rains today, right? So here probability of E2 is 1 minus probability of E1, that is 1 minus 0.4, that is 0.6. Okay. Now we need to find probability of A, that is probability of raining tomorrow. So probability of A, that is by total theorem, probability of A is equal to probability of A given E1 into probability of E1 plus probability of A given E2 into probability of E2, right? That is equal to probability of A given E1 0.8 into probability of E1 0.4 plus probability of A given E2 0.7 into probability of E2 0.6. That is equal to 0.32 plus 0.42, right? That is equal to 0.74. So probability of raining tomorrow is 0.74. Next, section B. This section contains 4 questions of long answer type questions carrying 5 marks each. So 32nd question, draw the graph sketch of the curve y is equal to 20 cos 2x where pi by 6 less than or equal to x less than or equal to pi by 3. Using integration, find the area of the region bounded by the curve y is equal to 20 cos 2x from the ordinates x is equal to pi by 6 to x is equal to pi by 3 and the x-axis. It's very simple question. You just see, try to draw the rough sketch of y is equal to 20 cos 2x. See, first of all, it is given that pi by 6 less than or equal to x less than or equal to pi by 3. Here x values are between pi by 6 and pi by 3. Okay. So you just plot the points that is on the x-axis only pi by 6 to pi by 3 and standard angles. Okay. So here pi by 6 starting from pi by 6, then pi by 4, then pi by 3. Okay. That's all. After that, see, let's substitute the values of x one by one. Starting from pi by 6. Okay. So first of all, what is our function? Y is equal to 20 cos 2x. Okay. Substitute x is equal to pi by 6. X is equal to pi by 6 cos pi, 2 into pi by 6, that is pi by 3. What is cos pi by 3? Cos pi by 3, that is cos 60 is 1 by 2. Right. So 20 into 1 by 2, that is 10. Now here we have to take the points on y axis. Right. So here it will be, let's take 5, 10, 20. Okay. So here we have got y is equal to 10, right? When x is equal to pi by 6. So plot the point pi by 6, 10. So it is the point pi by 6, 10. When x is equal to pi by 6, y is equal to 10. Next, let's substitute x is equal to pi by 4. So when x is equal to pi by 4, y is equal to 20 cos 2 into pi by 4, that is cos pi by 2. So what is the value of cos pi by 2? 0, right? So 20 into 0, that is 0. So x is equal to pi by 4. When x is equal to pi by 4, y is 0. So it is the point pi by 4, 0. Right? Next, x is equal to pi by 3. Substitute x is equal to pi by 3. So 20 cos 2 pi by 3. What is the value of cos 2 pi by 3? See, cos 2 pi by 3 can be written as cos of pi minus pi by 3. Right? Pi minus in second quadrant. Pi minus pi by 3 lies in second quadrant. In second quadrant, only sine and cosec are positive. Cos is negative. Right? Therefore, cos of pi, since it is pi, cos itself. Okay? So, cos of, it is minus because in second quadrant, cos is negative. Okay? So, minus cos pi by 3. Okay? So, what is cos pi by 3? Cos 60 is 1 by 2. So, it is minus 1 by 2. Therefore, it is 20 into minus 1 by 2, that is minus 10. So when x is equal to pi by 3, y is equal to minus 10. So we have to take the values of on the y axis also. Okay. So here we will take minus 5, minus 10, minus 20. Okay. When x is equal to pi by 3, y is equal to minus 10. So it is the point. Okay. Now let's join this point. So it is already mentioned rough sketch of the curve. Okay. So here it will be like this. Okay. And here next we have to find the region. Okay. Find the area of the region bounded by the curve y is equal to 20 cos 2x from the ordinates x is equal to pi by 6 to x is equal to pi by 3. So it is the region, right? See, x is equal to pi by 6 to x is equal to pi by 3. So the bounded region is, these are the bounded region. So we have to find the area of this shaded region. That is, so first we will find the area of this region plus area of this region. Okay. Now using integration. So required area is equal to integral pi by 6 to pi by 4. Okay. Area of this region from pi by 6 to pi by 4. Right. Okay. The values of x pi by 6 to pi by 4. Pi by 6 to pi by 4. The function is nothing but under the curve is y is equal to 20 cos 2x. 20 cos 2x dx plus area of this region x values between from pi by 4 to pi by 3. Right. So integral pi by 4 to pi by 3 20 cos 2x dx. Now integrate it. 20 is common. 20 is the constant. Let's take it out. 20 into cos 2x. Integral of cos 2x. Integral of cos x is sin x. Integral of cos 2x is sin 2x divided by 2. Okay. And limit pi by 6 to pi by 4. Plus integral of pi by 4 to pi by 3. 20 cos 2x. 20 is common. So 20 into, here let's integrate it. Cos 2x is sin 2x divided by 2 pi by 4 to pi by 3. Okay. And it should be the positive values. Okay. So here 20 into 1 by 2, that will be 10. Okay. 10 into, now substitute the values of x. So sin 2 into pi by 4, sin pi by 2, that is 1. Minus, okay, 1 by 2 we have already taken it out. Okay. Then next x is equal to pi by 6. 2 into pi by 6, that is pi by 3. Sin pi by 3, that is sin 60 is root 3 by 2. Plus 10 into, here, see here sin pi by 3, that is 2 pi by 3. Sin 2 pi by 3 is sin pi by 3 itself, because it lies to sin 2 pi by 3 is pi minus pi by 3 in second quadrant. In second quadrant sign is positive, so sin pi by 3. So root 3 pi by 2, see root 3 by 2 minus, see pi by 4, that is sin pi by 2, 1. So it will be negative values, right? So it should be positive. Okay, therefore here we can write it is, let's take the modulus. Okay, it should be positive. Okay, here when we integrate and after substituting the limits, we will get negative values. Okay, it should be positive. Therefore, we will take the modulus. Okay, so here we will take 1 minus root 3 by 2. Okay, if it is root 3 by 2 minus 1, it is a negative value, right? Because root 3 by 2 is greater than 1, right? So therefore, we will take 1 minus root 3 by 2. Therefore, see here it is 20 into 10 plus 10. Same thing, right? Same value number. That is 1 minus root 3 by 2. 1 minus root 3 by 2. Therefore 10 plus 10, 20. 20 into 1 minus root 3 by 2 square units. It is the required area. Third question. The equation of the path traversed by the ball headed by the footballer is y is equal to ax square plus bx plus c, where 0 less than or equal to x less than or equal to 14 and a, b, c belongs to R and a not equal to 0. With respect to a xy coordinate system in the vertical plane, the ball passes through the points 2, 15, 4, 25 and 14, 15. Determine the values of A, B and C by solving the system of linear equations in A, B and C using matrix method. Also find the equation of the path traversed by the ball. So here in matrix we have studied that finding the solutions of system of linear equations. Here system of linear equations are not given, but it is given that the ball passes through the points 215, 425 and 1415 and equation of the path traversed by the ball is y is equal to ax square plus bx plus c. So here first of all let's write the equation, system of linear equations, okay, substituting these values, okay. It is the equation. So equation of the path traversed by the ball. Okay, so here y is equal to ax square plus bx plus c is the equation. Now let's substitute the points one by one. X is equal to 2, y is equal to 15. Y is equal to 15, x is equal to 2, that is 4a plus 2b plus c. Next let's substitute this value, this point 425. X is equal to 4, y is equal to 25. Y is equal to 25, x is equal to 4, 4 square 16a plus 4b plus c. Next is 15, y is equal to 15, x is equal to 14. So 14 square 196a plus 14b plus c. Okay, now we have got system of linear equations. Here we have to find the values of a, b and c. Okay, so this set of equations can be expressed in the form ax is equal to b, right? Here we will find x is equal to a inverse b. We will find x, that is matrix x. Okay, so first of all let's write this set of equations in the expressed in the form of ax is equal to b. Okay, that is a is 4, 2, 1, 16, 4, 1, 196, 14, 1 and x is a, b, c. Okay, a, b, c, that is equal to b is 15, 25, 15, 25, 15, right? Okay. Now what we have to find? We have to find the values of ABC. We know that is x, right? Matrix x. So x is equal to a inverse b. So what is a? A is this one. B is 15, matrix 15, 25, 15. So here we need to find a inverse. To find a inverse, we need to find determinant of a and add j, right? To find add j, we have to find the cofactor matrix. So first of all, let's find determinant of a. Determinant of a, that is equal to 4, 2, 1, 16, 4, 1, 196, 41. That is equal to 4 into 4 minus 14 minus 2 into 16 minus 196, 16 minus 196 plus 1 into 16 into 14. Okay, 224 minus 196 into 4. 196 into 4. 784. Okay, that is minus 10 into 4 minus 40. Here it is minus 180, right? Minus 180 into 2 minus, that is plus 360. Plus here 560, right? Plus, sorry, minus 560. Minus 560, that is equal to, so plus 360 minus 560 minus 200 minus 200 minus 40 minus 240, it is not equal to 0. We have got determinant A is not equal to 0, therefore A inverse exists. Okay, Therefore, A inverse exists. Now, let's find A inverse. To find the A inverse, we need to find at J. To find at J, we have to find cofactor matrix. So, at J is nothing but the transpose of cofactor matrix. So, it is the at J matrix minus 10, 180, minus 560, 12, minus 192, 336, minus 2, 12, minus 60. So, here next we have to find A inverse, right? A inverse is equal to 1 by determinant A into at J. So, what is 1 by determinant A? That is minus 1 by 240, right? 240 into at J is minus 10, 12, minus 2, 180, minus 192, 12, minus 560, 336 in minus 60. Okay. So, it is A inverse. Now, what we have to find? We have to find the matrix X, that is values of A, B, C, right? So, matrix X, that is equal to A inverse B, right? So, that is equal to A inverse is this one, minus 1 by 240 into minus 10, 12, minus 2, 180, minus 192, 12, minus 560, 336, minus 60 into B, matrix B. Matrix B is 15, 25, 50. So, here 5 is common. We can take 5 outside from the matrix. So, it will be minus 5 divided by 240 into minus 10, 12, minus 2, 180, minus 192, 12, minus 560, 336 minus 16 into B is, we have taken 5 outside. So, it will be here 3, 5, 3. Okay. Now, multiply these values. You will get the values of A, B and C. So, this multiplication is equal to, so its multiplication is minus 5 by 240 into this multiplication of these two matrices is 24 minus 384 minus 48. So, that is matrix X is equal to this one. Now, let's multiply these values. Minus 5 by 240 into 24, that is, so this, what is this matrix? X is equal to ABC, right? So, ABC is equal to these values, that is minus 5 by 240 into 24 minus 384 minus 48. Now, let's find one by one. A is equal to, that is minus 5 by 240 into 24, that is minus 1 by 2, and B is equal to minus 5 by 240 into 384, that is B is equal to 8, C is equal to 1. Okay. So, here the values of A, B and C are minus 1 by 2, 8 and 1 respectively. Next, see, one more question is there. Also find the equation of the path traversed by the ball. See, equation of the path traversed by the ball is given y is equal to ax square plus bx plus c. Now, here substitute the values of A, B and C, okay, to get the equation of this. That is, substitute A is equal to minus 1 by 2, that is minus 1 by 2 x square plus 8x plus 1. So, it is the equation of the path traversed by the ball. Next, 34th question. Here also there are two questions, or question is there. 34th A. If f from R to R is defined by f of x is equal to modulus x whole cube, show that f double dash of x exists for all real x and find it. Here we know defining modulus x function, right? So similarly, we can define modulus x whole cube. So modulus x whole cube is equal to minus x cube when x less than 0, x cube when x greater than 0. Okay, so here, and we studied that a differentiable function. See, if left hand derivative is equal to right hand derivative of a function at a point x is equal to c, then we say that function is differentiable at x is equal to c. Right? So here, first of all, let's take let x is equal to 0. Okay? So here, first of all, let's take whether this function is differentiable at x is equal to 0 or not. That is, so for that we have to find left hand derivative at x is equal to 0 and right hand derivative at x is equal to 0, right? So here left hand derivative at x is equal to 0 is limit x tends to 0 minus f of x minus f of 0. It is the definition of the differentiability, right? So f of x minus f of 0 divided by x minus 0, right? That is equal to limit x tends to 0 minus f of x. Here what is f of x? See, x tends to 0 minus means x is approaching to 0. Okay, it is less than 0. Not 0, not greater than 0. It is approaching to 0. 0 minus means less than 0. Okay, so when x is less than 0, f of x is minus x cube, right? So minus x cube, f of 0 is 0 divided by x minus 0, x, right? So here minus x cube divided by x is minus x. So we have to apply the limit, okay? Limit x tends to 0 minus x, right? X cancelled, minus x square, okay? Now apply the limit, substitute x is equal to 0, we will get 0. So we have got left hand derivative at x is equal to 0 is 0. Next we will find the right hand derivative, okay? That is, right hand derivative at x is equal to 0 is limit x tends to 0 plus f of x minus f of 0 divided by x minus 0. That is equal to, here what is f of x? Here x tends to 0 plus, x is approaching to 0 plus, that is greater than 0. Okay, it is near to 0 and close to 0 and greater than 0. So when x is greater than 0, the function is x cube, right? So x cube limit x tends to 0 plus f of, what is f of x? X cube, right? X cube minus 0 divided by x. That is equal to x square cancelled, sorry, x cancelled. So x square limit x tends to 0 plus f of x. Sorry, x square. Okay. Now apply the limit, that is substituting x is equal to 0, you will get 0. So here right hand derivative is also 0, right? So here according to the definition of the derivative, we can say this function, which function? This modulus of x cube is differentiable at x is equal to 0. Okay, that is modulus of x cube is differentiable at x is equal to 0. Okay, here what we have to prove, that is we have to show that is second derivative of f of x. Okay, not first derivative, second derivative of f of x exists. Now here we have proved first derivative, that is, see here we have proved this one, that is first derivative, that is f dash of x is, f dash of x exists. Okay, here f dash of x exists. Next here, next again we have to find the second derivative. That means we have to prove f double dash of x exists, right? For that we need to prove, that is f dash of x is differentiable at any point. Okay, f dash of x is differentiable at any point. So then we can say f double dash of x exists. Here now we have proved this f of x is equal to modulus x whole cube is differentiable at x is equal to 0. Therefore, that means f dash of x exists. Okay. Next we have to prove f double dash of x exists, right? That means we need to show, that is f dash of x is differentiable at any point. Okay. Now let's take x is equal to 0. Okay. So here what is f dash of x function? F dash of x is, what is the derivative of this one? minus 3x square when x less than 0 and 3x square when x greater than or equal to 0. Right? Next, again we will take the same process. Okay. So here same method, by the same method we can prove. So limit x tends to 0 minus, okay, here f dash of x minus f dash of 0 divided by x minus 0. Okay, that is equal to, what is f dash of x? Here x tends to 0 minus means x less than 0. Okay, values of x less than 0. Here when x less than 0, what is f dash of x? Minus 3x square. So minus 3x square, and when x is equal to 0, see when you substitute x is equal to 0, you will get it is 0, right? So it is 0 divided by x minus 0, x. That is equal to, okay, we have to write limit, okay, limit x tends to 0 or 0 minus. So here x cancelled, so minus 3x. Limit x tends to 0 minus 3x. Now put x is equal to 0. So when we substitute x is equal to 0, we will get 0. Right? Next we will find right hand derivative. Okay? It is left hand derivative. Next right hand derivative, that is equal to limit x tends to 0 plus f dash of x minus f dash of 0 divided by x minus 0. So here x tends to 0 plus, okay, x approaches to 0 plus means greater than 0. It is close to 0 and greater than 0. Therefore, when x is greater than 0, what is f dash of x? 3x square, right? So limit x tends to 0, 3x square minus 0 divided by x minus 0, right? That is limit x tends to 0 plus x cancelled 3x. Now apply the limit, we get 0. Right? See, here we have got a left hand derivative is equal to right hand derivative. That means this f dash of x, okay, this f dash of x is differentiable at x is equal to 0. Okay, so therefore f dash of x is differentiable at x is equal to 0. That means f double dash of x exists. Okay, see here, if f of x is differentiable at x is equal to 0 means f dash of x exists, right? If f dash of x is differentiable at x is equal to 0, that means f double dash of x exists. F double dash of x exists, right? Now what is f double dash of x? See here our question is show that f double dash of x exists for all real values of x and find it. We have to find what is the value, that is means f dash of x. What is f dash of x? That means second derivative of modulus of x cube. That is here. Say its second derivative. It is the first derivative and differentiate it again with respect to x. So it is minus 6x when x less than 0 and it is 6x when x greater than or equal to 0. So it is the f double dash of x. Next question, 34th B. If x minus a whole square plus y minus b whole square is equal to c square for some c greater than 0, prove that 1 plus dy by dx whole square whole raised to 3 by 2 divided by d square y by dx square is a constant and independent of a and b. So here we have to find dy by dx and d square y by dx square from this equation. Okay, and we have to prove it is a constant and independent of a and b. That is, there should not be a and b terms, right? So here we have to find dy by dx and d square y by dx square, right? So directly we cannot find dy by dx and d square y by dx square. It needs appropriate substitution, right? So here for that, let's take x minus a. Let x minus a is equal to c cos theta and y minus b is equal to c sin theta. See, if you substitute this one here, you will get right side c square, right? Okay. Now, what is dx by d theta? Dx by d theta is minus c sin theta, right? What is dy by d theta? That is c cos theta. Okay. Now, we will get dy by dx. What is dy by dx? dy by d theta divided by dx by d theta, right? That is c cos theta divided by minus c sin theta, that is c cancelled, so minus cot theta. Okay. Now dy by dx is equal to minus cot theta. Okay. Here next let's differentiate with respect to theta on both sides. Okay. Because here we need to find d square y by dx square, right? So directly we cannot find because in right side the terms are in theta, right? So here d by d theta of dy by dx is equal to d by d theta of minus cot theta. What is the derivative of cot theta? Minus cosec square theta. So minus minus become plus. So it is cosec square theta. Okay. Now here we have got d by d theta of dy by dx. Here we need to find d square y by dx square, right? So in left side we have to make it in dy by dx. So we have to cancel this d theta, right? So for that, see, this can be written as d by dx of dy by dx. See, now it become d square y by dx square into dx by d theta. See, dx cancel. Then it will be d by d theta of dy by dx. This one same, right? Therefore, this can be written as this one. Okay, that is equal to cosec square theta. See, it is nothing but d square y by dx square into dx by d theta. We have dx by d theta, right? Minus c sin theta. That is equal to cosec square theta. Okay. That implies what is d square y by dx square? D square y by dx square is equal to, take this minus c sin theta here. So it will be minus 1 by c sin theta, right? So 1 by sin theta is nothing but cosec theta, right? So it will be cosec cube theta. That is minus cosec cube theta divided by this c. Okay. Now see, now we have dy by dx and d square y by dx square. Substitute this one here. Okay. Therefore 1 plus dy by dx whole square whole raised to 3 by 2 divided by d square y by dx square, that is equal to 1 plus, what is dy by dx? Minus cos theta, right? So dy by dx whole square is plus cos cot square theta whole raised to 3 by 2 divided by, here what is d square y by dx square theta? Sorry, d square y by dx square, that is minus cosec cube theta divided by c. This c will be, come to numerator, right? So that is equal to minus c. See, what is 1 plus cot square theta? Cosec square theta, right? So cosec square theta whole raised to 3 by 2 divided by cosec cube theta, right? That is equal to, see this square, this 2 cancelled, right? Now it become cosec cube theta. So cosec cube theta cancelled. That is minus c cosec cube theta divided by cosec cube theta. Okay, that is equal to, it is cancelled, minus c. Okay, see, now we have got, it's a constant and independent of a and b, which is constant and independent of a and b. Next, 35th question. Here also there are 2 questions, or question is there. So 35th, A, find the shortest distance between the lines L1 and L2 whose vector equations are vector r is equal to minus I minus j minus k plus lambda into 7i minus 6j plus k, and vector r is equal to 3i plus 5j plus 7k plus mu into I minus 2j plus k, where lambda and mu are parameters. So here we have to find the shortest distance between 2 lines. Direct questions, right? So we know the formula, right? So here shortest distance between 2 lines, we know that shortest distance between the two lines with vector equations. Vector r is equal to vector a1 plus lambda vector b1, and vector r is equal to vector a2 plus mu vector b2 is, what is the shortest distance formula? Modulus vector b1 cross vector b2 dot vector a2 minus vector a1 divided by modulus of vector b1 cross vector b2. Okay, so it is the shortest distance between two lines formula. Okay, so here first of all two equations, that is two lines, equations of two lines are given in vector form, and let's write vector a1 a2 and vector b1 b2. Vector a1 is equal to, see, it is of the form vector r is equal to vector a1 plus lambda vector b1, right? So vector a1 is equal to minus I minus j minus k, and vector a2 is equal to, it is vector a2, okay, vector r is equal to vector a2 plus mu vector b2. Vector a2 is equal to 3i plus 5j plus 7k, and vector b1 is equal to 7i minus 6j plus k. Vector b2 is equal to I minus 2j plus k. Okay, then find the shortest distance. We have to find these terms one by one. So first of all, let's find b1 cross b2. Okay, b1 cross b2, that is determinant I, j, k, components of b1 7 minus 6 1, b2 1 minus 2 1, that is equal to I into minus 6 plus 2 minus j into 7 minus 1 plus k into minus 14 plus 6 minus 14 plus 6. So that is equal to minus 4i, 7 minus 1 6, so minus 6j, it is minus 14 plus 6, that is minus 8, right, minus 8k. So it is b1, vector b1 cross vector b2. Next let's find vector a2 minus vector a1. What is vector a2? This one, right? So vector a2 minus vector a1, that is 3 minus 1 4, right? 3 plus 1 4. So 4i. Next plus 5 minus 1, that is 6. So plus 6j plus 7 minus 1 8, 8k. Vector a2 minus vector a1 is equal to 4i plus 6j plus 8k. Next, let's find modulus of vector b1 cross vector b2. So modulus of vector b1 cross vector b2 is equal to, that is square root of minus 4 square 16 plus 6 square minus 6 square 36 plus 64, that is equal to square root of, it is 52 106, right, 116, okay, that is equal to, okay, square root of 116. So here now let's substitute this one here. Okay, therefore shortest distance between shortest distance is equal to, okay, shortest distance between these two lines, given two lines are, is equal to modulus of vector b1 cross vector b2, that is minus 4i minus 6j minus 8k dot vector a2 minus vector a1 4i plus 6j plus 8k divided by modulus of vector b1 cross vector b2 is square root of 116. Okay, that is equal to, now find the dot product of these two vectors. Minus 4 into 4 minus 16, right, minus 16, minus 6 into 6 minus 36, minus 8 into 8 minus 64, take minus outside, it's in the modulus, okay, because the shortest distance is always positive, right? Okay, divided by square root of 116. So here it will be, when we take minus outside, so after taking the modulus, it will be positive, right? So 16 plus 36 plus 64, that is 116 divided by root of 116, that is equal to root 116 cancelled, so root of 116. It is the shortest distance between given two lines. Next question, 35th B. Find the image of the point 1, 2, 1 with respect to the line x minus 3 by 1 is equal to y plus 1 divided by 2 is equal to z minus 1 divided by 3. Also find the equation of the line joining the given point and its image. So here first of all let's find the image of the point 1, 2, 1 and equation of a line in Cartesian form is given, right? So here suppose it is the three-dimensional space. Okay, suppose it is the line vector r, okay, and let this point P be 1, 2, 1, okay, it is given, and let ABC be the point, ABC be the image of the point 1, 2, 1, okay. Now here, since it is an image, let this be Q, okay. So since it is an image of the 1, 2, 1, here the distance is, say suppose it is R. So here PR is equal to RQ, right? Because Q is the image of 1, 2, 1. Therefore here we can write PR is equal to RQ. Therefore R is the midpoint of P and Q, right? R is the midpoint of P and Q. Therefore we can write the coordinates of R, right? Because we have studied finding the midpoint of a line joining two points, right? That is coordinates of R is 1 plus A divided by 2, 2 plus B divided by 2, 1 plus C divided by 2. Okay. So here we have to find the A, B and C, right? So for that, see here it is the midpoint of this line, right? And this point R is on the line vector R, right? See here this vector, this line equation is given, okay? So here this R is lying on this line. We can find the coordinates of this R, right? That is here see x minus 3 by 1, it is the equation of this line, is equal to y plus 1 divided by 2 is equal to z minus 1 divided by 3 is equal to lambda. Okay. So from this we can find the coordinates of points on the line. Okay. We can find the coordinates of points on the line. That is x, y, z, right? Find x, y, z. X minus 3 by 1 is equal to lambda implies x is equal to lambda plus 3, right? And y is equal to y plus 1 divided by 2 is equal to lambda implies y is equal to 2 lambda minus 1, right? And z is equal to 3 lambda plus 1, right? So x, y, z. So these coordinates are the coordinates of points on the line, right? So here we can write coordinate of R is coordinates of R, that is lambda plus 3, 2 lambda minus 1, 3 lambda plus 1. Okay. Now here we have to find the value of lambda. So how to find? See, if we know value of lambda, then we can compare this with this, then so that we can find the values of ABC, right? So here to find the value of lambda, here we will take direction ratios. Okay. See here this image, that is it is the perpendicular, right? Because it is perpendicular to the mirror. Okay. Therefore here PQ is perpendicular to this line. Okay. And what is the direction ratios of this line? See, it is the equation of the line, right? So what is the direction ratios of the line? 1, 2, 3. right? 1, 2, 3 are direction ratios of the line, right? So direction ratios of the line R is 1, 2, 3. Okay. Then after that, next what is the direction ratios of PQ? Direction ratios of PQ. We have learnt that direction ratios of a line joining two points, right? That is, if x1, y1, z1, x2, y2, z2, then x2 minus x1, y2 minus y1, z2 minus z1 are the direction ratios of the line, right? So here, what is the direction ratios of PR? Let's find direction ratios of PR. Direction ratios of PR. See, what is the coordinates of R? Here we have to find the value of lambda, right? So let's take these coordinates, okay? That is lambda plus 3, 2 lambda minus 1, 3 lambda plus 1. And P is 1, 2, 1. Therefore, what are the direction ratios? So lambda plus 3 minus 1, then 2 lambda minus 1 minus 2, okay, because x2 minus x1, y2 minus y1, z2 minus z1 are the direction ratios of the line joining two points x1, y1, z1, x2, y2, z2, right? Okay, so here x1, y1, z1, 1, 2, 1 and x2, y2, z2 are lambda plus 3, 2 lambda minus 1, 3 lambda plus 1, okay, coordinates of R, right? So here next is 3 lambda plus 1 minus 1. So that is lambda plus 3 minus 1, lambda plus 2. Here 2 lambda minus 3, 3 lambda. Okay, these are the direction ratios of line PR. Okay, and we know that this line PR is perpendicular to the line R. Okay, PR is perpendicular to the line. Therefore, dot product of these vectors is 0. Right? Dot product of these vectors is 0. So here we can write, see, these are the direction ratios, right? Direction ratios of PR is this one. Direction ratios of R is 1, 2, 3. Okay? These two. So we can write the vector, right? So here we can write, therefore, since PR perpendicular to R. Okay? Or we can write, okay, line AB. Okay, line AB. So PR perpendicular to AB. 1 into lambda plus 2, that is dot product of these two vectors is 0. Okay, because these two lines are perpendicular. So 1 into lambda plus 2 plus 2 into 2 lambda minus 3 plus 3 into 3 lambda, that is equal to 0. Okay, now let's find the lambda value. So lambda plus 2, here 4 lambda plus 4 lambda minus 6 plus 9 lambda is equal to 0. So lambda, 5 lambda, 14 lambda, right? So 14 lambda, 2 minus 6 minus 4 is equal to 4. So lambda is equal to 4 divided by 14, that is 2 by 7. Right? So here we have got lambda is equal to 2 by 7. Then next we substitute this lambda value in this, okay, coordinates of R, because here we have to find the values of ABC, right? That is, values of ABC means we have to find the image of the point, this one, right? So here we have to find the value of ABC. Therefore, we need to find the value of lambda. We have got a lambda value. Then substitute this lambda here. Then compare this with this one, so that we will get value of ABC. Okay, we have got value of lambda. Now we will substitute this lambda in this. Okay, these coordinates. So coordinates of R is lambda plus 3 that is 2 by 7 plus 3, and 2 into 2 by 7, 4 by 7 minus 1, 3 into 2 by 7, that is 6 by 7 plus 1, that is 21 plus 2, that is 23 by 7, and 4 by 7, that is 4 minus 7 minus 3 by 7, and here it is 7 plus 6, 13 by 7. Okay. So here these are the coordinates of R, and coordinates of R is 1 plus A by 2, 2 plus B by 2, 1 plus C by 2. Compare this. Okay. Comparing these coordinates, we will get 1 plus A divided by 2 is equal to 23 by 7. 2 plus B divided by 2 is equal to minus 3 by 7. 1 plus C divided by 2 is equal to 13 by 7. Okay. Then here next we will find the values of A, B and C. That is, here 1 plus A is equal to, take these two here, so 46 by 7, and 2 plus B is equal to minus 3 by 7, 3 into 2 minus 6 by 7, and 1 plus C is equal to 26 by 7. Okay. So here A is equal to 46 by 7 minus 1, B is equal to minus 6 by 7 minus 2, C is equal to 26 by 7 minus 1. So here it is, A is equal to 46 minus 7, that is 39 divided by 7. Okay. So next B is equal to minus 14 minus 6 minus 20 divided by 7. C is equal to, it is 19 divided by 7, right? Okay. Now we have got A, B and C. Okay, values of A, B and C, that is nothing but image, that is image of the point 1 to 1. Okay, our first question is find the image of the point, right? Therefore, image of the point 1 to 1 is 39 divided by 7 minus 20 divided by 7, 19 divided by 7. Next question, see, it's very simple question. Find the equation of the line joining the given point and its image. See, we have studied already, right? We have a formula also. That is equation of a line, that is vector equation or partition equation of a line joining the points, line joining the points x1, y1, z1 and x2, y2, z2 are, okay, z2 is, here what is the formula? X minus x1 divided by x2 minus x1, that is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1. Okay, that is equation of a line joining two points x1, y1, z1 and x2, y2, z2 are x1, x minus x1 divided by x2 minus x1, y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1. Okay, it is the equation of a line when 2 points on the line are given. Okay, so here, see, here we have to find the equation of this line. That is, it is given that find the equation of the line joining the given point. It is the given point and the image of the point. What is the image? ABC, that is 39 by 7 minus 20 by 7, 19 by 7. Right? So now x1, y1, z1, 1 to 1, x1, y1, z1 and these points are x2, y2, z2. Okay. Now let's substitute these values. We will get the equation of the line. Okay. So substitute x minus x1. x1 is 1 divided by x2 minus x1. x2 is 39 by 7 minus 1. Okay. That is equal to y minus y1. What is y? Y is y itself. Okay. Y minus y1 is 2 divided by y2 minus 20 by 7 minus y1 2. Okay. Is equal to z minus z1 1 divided by Z2 is 19 by 7 minus 1. Next, simplify this one. See here, we will get x minus 1 divided by, here 39 minus 7 divided by 7 is there. So that 7 will come to numerator, right? So let's write 7 into. Okay, 39 minus 7 is 32. Okay, that is equal to, here y minus 2 divided by, here minus 20 and minus 14, that is minus 34, right? Divided by 7. Here also 7 into y minus 2 divided by minus 34. Okay, that is equal to, next, here 19 minus 7, that is 12. So here also 7 is there. 7 into z minus 1 divided by 12. Okay. Now all these 7 cancel. Okay. So here equation will be x minus 1 by 32 is equal to minus, that is y minus 2 divided by minus 34 is equal to z minus 1 divided by 12. See here 4 is common, right? Not 4. 2 is common, right? So here we can take 2 outside and cancel. Okay. That implies x minus 1 divided by 16 is equal to y minus 2 divided by minus 17 is equal to z minus 1 divided by 6. So it is the required line equation of the line. Next, section E. This section contains 3 case study questions, each carrying 4 marks. So first, 36th question. Ramesh, the owner of a sweet selling shop, purchased some rectangular cardboard sheets, dimension 25 cm by 40 cm to make container packets without top. Okay. Let x centimeter be the length of the side of the square to be cut out from each corner to give that sheet of the shape of the container by folding up the flaps. See, we have already solved this question. Okay, that is in applications of derivatives, right? Okay, so here first question, there are 3 questions. Okay, based on the above information, about answer the following questions. Express, first question, express the volume V of each container as function of x only. It's very simple, right? See, here actually he has to make a container for sweets, right? So here it is given the cardboard sheet's dimension is 25 cm by 40 cm. Therefore, he has to make a cuboid, means container without top, right? So here he has to cut off squares from each corner, okay, and squares of length x centimeter. It is given x centimeter is the length of the side of the square. So he has to cut off the squares of length x centimeter from each corner. Okay, now here we have to, first question is we have to find the volume. So after the container means, so what is the container shape? Shape is cuboid, right? So we have to find the volume of cuboid. So what is volume of cuboid? Formula L into B into H, length into breadth into height. Okay, now let's find what is L, that is length of the container. Here length of the sheet is 40 centimeter, right? So and here he has to cut off 2 squares from each side, right? So here the length will be 40 minus, after removing the squares, so what is the length? 40 minus 2x, because minus x, that is minus 2x, because he has to cut out 2 squares from each side, right? So L is equal to 20 minus 2x. And what is B? The breadth of cardboard sheet is 25 centimeter. Okay. Therefore, here after removing the squares, so B is equal to 25 minus 2x. Okay, because here square length is for x centimeter. Okay. Then, so L and B. Now, what is H? H is nothing but height of the box, right? So height is nothing but that is length of the square. Okay, when we fold it, that is the height is nothing but length of the square. So what is the length of the square? X centimeter, right? Therefore, H is equal to X centimeter. Okay. Now let's substitute these values here. So volume of cuboid is equal to 40 minus 2x into 25 minus 2x into x. Okay. That is equal to 40 into 25 minus 2x. Okay. Minus 2x into 25 minus 2x into x. Okay. That is equal to 40 into 25, 1000, right? 1000 minus 80x minus 50x minus into minus plus 4x square into x. That is equal to 1000x minus 8x, sorry, not 80, okay, 80x minus 50, that is 130x, so minus 130 into x square, okay, x into x square plus 4x cube, okay, that is equal to, here 2 is common, right? So let's take 2 outside, 2 into 500x, right, minus 65x square plus 2x cube. So it is the volume, that is unit is centimeter, right? Centimeter cube. Okay. So it is the volume of the container. So and it is the function of x only. Okay. Next, in this second question is find dv by dx. We have got v is equal to 2 into 500x minus 6x square plus 2x cube. Find dv by dx by differentiating with respect to x. Right? So dv by dx is equal to 2 into derivative of 500x is 500 minus, it is 65. Okay. We have got v is equal to 2 into 500x minus 65x square plus 2x cube. So it is 65 into 2, 130x plus 2 into 3, 6x, right? 6x square. Okay. Now here 2 is common. Let's take it out. So 2 into 2, 4. Okay. So 4 into 250 minus 65x plus 3x square. Okay. Now this can be written as 4 into 250, here this can be written as minus 50x minus 15x, right? Minus 50x minus 15x plus 3x square. That is equal to, here say in these two terms we can take, yes, see these two terms we can take x outside, okay? These two terms, okay? So it is equal to x into 3x minus 50, okay? These two terms. So from these two terms we can take x outside. So it will be x into 3x minus 50, okay? After that, and next these two terms, right? These two terms. So from this we will take 3 outside, okay? That is minus 3 into, sorry, 5, take 5, okay? 5 into 3x minus 250 divided by 5, 50, right? Okay. So 50. So here we have taken 5 outside, okay? So see, now we have got the same term, right? Now let's take 3x minus 50 outside. So it will be 3x minus 50 into x minus 5. 4 is here. 4x into 3x minus 4 into x into 3x minus 50 minus 5 into 3x minus 50. Okay. That is 4 into 3x minus 50 into x minus 5. It is our dv by dx. Next question is third question. For what value of x, the volume of each container is maximum. See, there are two questions. Okay, in third, A or B. Okay, or question is here. Okay, A, for what value of x, the volume of each container is maximum. This also we have studied, right? Finding the maximum and the minimum values of the function. So here we have to find at what value of x this function v of x is maximum. So for that, see, we have found already dv by dx is equal to 4 into x minus 5 into 3x minus 50, right? So to find the values of x, see, first of all we have to put dv by dx is equal to 0, right? So dv by dx is equal to 0 implies x is equal to 5 or x is equal to 5 or x is equal to 3x is equal to 50. That means x is equal to 50 divided by 3, right? Now you just substitute, see, x is equal to 50 by 3. What is our breadth? That is b is equal to 25 minus 2x, right? So here you substitute x is equal to 50 by 3. See, here we will get b is equal to negative value. See, it is the length. Length is always positive, right? So here we will get b is negative. Okay, when we substitute x is equal to this 50 by 3, we will get b is equal to negative value. Okay, because 50 minus 2 into 50, that is 100 divided by 3, because it is greater than 25, right? So it will be minus. So therefore x is equal to 50 by 3 is not possible. Okay, that is 25 minus 100 divided by 3, it is less than 0. Therefore x is equal to 50 by 3 is not possible. Okay, so here like that you have to check. Okay, then x is equal to 5 is possible. If you want, you can check. Okay, now x value is 5. Okay, after that next we have to show it is maximum. Okay, at which point this function v of x is maximum. For that we need to find f double dash of x, means here v double dash of x or d square v by dx square, right? So let's find d square. What is dv by dx? dv by dx is equal to this one, right? So let's expand this one. 4 into 3x square minus 65x minus 250, right? So therefore d square v by dx square is equal to 4 into 6x minus 65, right? 6x minus 65. Okay. Now substitute x is equal to 5. We have to check whether this d square v by dx square less than 0 or greater than 0, right? Okay. So put x is equal to 5 in this. So here d square v by dx square is equal to 4 into 6 into 5, 30 minus 65. That is 4 into 30 minus 65, 35. Minus 35, right? Minus 35. So 4 into 5, 20. 4 into 12, that is 140. So minus 140, right? So here minus 140, therefore it is less than 0. That means here we have got second derivative, that is v double dash or d square v by dx square less than 0. That means this function v of x is maximum at x is equal to 5. Okay, when we substitute x is equal to 5, we have got the second derivative is less than 0. Right? We have already studied this. F double dash of x is less than 0. Then f of x is maximum at that point. Okay. So here we can say v of x is maximum at x is equal to 5. For what value of x? X is equal to 5. This volume of each container, volume of this container is maximum. Next, third question or question B. Okay. Check whether V has a point of inflection at x is equal to 65 divided by 6 or not. See, To check this, V has a point of inflection at x is equal to 65 by 6 or not. See, you have to show V double dash means second derivative of V of x. That is V double dash of 65 by 6 is equal to 0. If you are getting V double dash of x, that is V double dash of not x is equal to 65 by 6 is equal to 0, then you can say this V has a point of inflection at the point 65 by 6. Okay. See, this one V double dash of x, so we have already found, right? That is V double dash of x means d square V by dx square, right? So V double dash of x is equal to 4 into 6x minus 65. We have got. Now we have to find, okay, we have to check whether V double dash of 65 by 6 is equal to 0 or not. Okay. So here V double dash of 65 by 6, that is equal to, substitute x is equal to 65 by 6. 4 into 6 into 65 by 6 minus 65. See, 6 cancelled, so it is equal to 0. See, here we have got V double dash of 65 by 6 is equal to 0. Therefore, hence this V has a point of inflection at x is equal to 65 by 6. That's all. Next case study, second question, 37th question. An organization conducted bike race under two different categories, boys and girls. In all, there were 250 participants. Among all of them, finally 3 from category 1 and 2 from category 2 were selected for the final race. Ravi forms 2 sets B and G with these participants for his college project. Okay. So the sets are, let B is equal to B1, B2, B3 and G is equal to G1, G2, where B represents the set of boys selected and G is the set of girls who were selected for the final race. So Ravi decides to explore these sets for various types of relations and functions. So the first question is, Ravi wishes to form all the relations possible from B to G. How many such relations are possible? See, in relations and functions, we learned that the number of relations from B to G is equal to number of relations from set B to set G is equal to 2 raised to number of elements of B, set B. So how many elements are there? 3, right? So 2 raised to 3 into number of elements of G, that is 2. Okay. So here number of relations from B to G is equal to 2 raised to number of elements of B into number of elements of G. Okay, keep it in your mind. Number of relations from B to G, set B to set G is 2 raised to number of elements of B into number of elements of G. Okay. So there are 3 elements in set B and there are 2 elements in set G. Therefore 2 raised to 3 into 2, that is 2 raised to 6. Therefore there are 2 raised to 6 relations from B to G. Okay. So first question answer is 2 raised to 6. Second question is, write the smallest equivalence relation on G. So here, what is an equivalence relation? If the relation is reflexive, symmetric and transitive, then the relation is equivalence relation. Okay. Now, here we need to find the smallest equivalence relation on G. Okay. So first of all, let's write the possible pairs on G. Possible pairs is equal to, so G1, G1 G1, G1. Here because we need to find the smallest equivalence relation on G. Okay. So G1, 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 G2, G2, G1, G2, G2. Okay. These are the possible pairs. Okay. Now let's check whether it is possible or it is satisfied for reflexive. Is it reflexive, symmetric and transitive? Okay. So for reflexive, here element that is A should be in the relation, right? That is same elements. A should be in the relation. So here G1, G1, G2, G2 should be in the relation, right? So it is there. Next is, so reflexive, for reflexive, G1, G1 and G2, G2 belongs to, okay, should be in the relation. Next is symmetric. See, if G1, G2 belongs to the relation, okay, if G1, G2 in the relation, then G2, G1 should be in the relation, right? So it is here. If G1, G2 in the relation, then G2, G1 is in the relation. Okay, should be in the relation. Now, that is, next is, so symmetric, for symmetric, if G1, G2 in the relation, then G2, G1 should be in the relation. Right? Okay. After that, transitive. See, for transitive, if G1, G2, if G1, G2 in the relation, G1, G2 and G2, G1, okay, if G1, G2, G2, G1 in the relation, then G1 should be in the relation, right? So G1 should be in the relation. So here, according to this, see, this relation is an equivalence relation, right? This relation is an equivalence relation, but here we have to find the smallest equivalence relation. See, if this relation has only the elements G1, G2, G2, see, all these will be possible. Okay, that is, if this set has only two elements, that is G1, G1 and G2, G2, it will be possible, right? So because here we need to find the smallest equivalence relation on G. See, if you want, say, we have already done such examples, right? So here G1, G1, G2, G2. Okay, if we have only these two elements, G1, G1, G2, G2, all this will be satisfied. Okay, therefore the smallest equivalence relation on G is G1, G1, G2, G2. It is an equivalence relation on G. But here we need to find the smallest equivalence relation. So here the smallest equivalence relation on G is G1, G1, G2, G2. Next, third question. Or question is there. Third A. Ravi defines a relation from B to B as R1 is equal to B1, B2, B to B1. Write the minimum ordered pairs to be added in R1 so that it becomes reflexive but not symmetric. Reflexive and symmetric but not transitive. Okay, so first of all, let's find the relation of A. Okay. So here it is given that, see, it is already given R1 is equal to B1, B2, B2, B1. Now we have to add some ordered pairs, that is minimum ordered pairs. Okay, minimum ordered pairs we have to add so that it should be reflexive but not symmetric. See, reflexive means what? That is A should be in the relation. Okay, so it should be for all the elements of B. Means that means B1, B1, B2, B2, B3, B3 belongs to the relation. Right? Therefore, here we can add. Okay, now for first here R1 is equal to B1, B2. This one we have to write, okay, B1, B2, B2, B1, and next we have to add minimum ordered pairs so that this relation should be reflexive but not symmetric. Reflexive means there should be B1, B1, B2, B2, B3, B3, okay. So B1, B1, B2, B2, B3, B3. See, now it become reflexive, okay, because all these elements are here in the relation. And here we have to check, see, it should not be symmetric. Now it is symmetric, right? Because if B1, B2 belongs to the relation, B2, B1 should be in the relation. So it is possible, right? So here this relation is symmetric, but we need not symmetric relation, right? So for that we have to add one more element, that is one more ordered pair, that is, let's add to B2, B3. See, we have added B2, B3. Okay, don't add B3, B2, then it will be again symmetric. Okay, because here, see, B2, B3 is in this relation, but B3, B2 is not in this relation. Therefore, this relation is the reflexive but not symmetric. Okay, so here 4 minimum ordered pairs added. Okay, B1, B1, B2, B2, B3, B3, B2, B3. So we have added 4 minimum ordered pairs to make reflexive, to become reflexive but not symmetric. Okay. Next B. See, what is B? See, B is reflexive and symmetric but not transitive. See, reflexive means these all elements should be there. Okay. And symmetric means if B1, B2 belongs to the relation, then B2, B1 should be there in the relation. If B2, B3 is in the relation, then B3, B2 should be in the relation, right? And it should not be the transitive. So transitive means if B1, B2 belongs to the relation, B2, B3 belongs to the relation, then B1, B3 should be in the relation. So here, see, we can add B1, B2 is already there, right? And let's add B2, B3, okay, B2, B3. Then we should not write B1, B3, okay. If we write this pair in this relation, if we add this pair, then it will be transitive, okay. So we can write the relation B1, B2, B2, B1. These two elements, these two pairs already there, okay. So, and next we have to add these three because for reflexive, okay. That is B1, B1, B2, B2, B3, B3, right? And it should be symmetric, right? It should be symmetric. Therefore, here, see, don't write this one. Okay, we can add this one because for not transitive, we have to add one more element. Okay, so let's write B2, B3. Then, is it enough? See, for symmetric, it should be symmetric, right? So for symmetric, see, B2, B3 is in this element, B3, B2 should be in this element, in this relation, right? Therefore, we have to add one more element, that is B3, B2. Then only it will become symmetric. Okay. Next, it should not be transitive. See, B1, B2 belongs to B1, B2 is in the relation, okay, and B2, B3 is in this relation, but B1, B3 is not in this relation. Therefore, it is not transitive. And it is symmetric, right? B1, B2 belongs to the relation, B2, B1 is in this relation. And transitive, reflexive also, it is not transitive. Okay. So here, for 1, 2, 3, 4, 5. Okay, 5 minimum ordered pairs are added to become reflexive and symmetric but not a transitive. Okay. Third B, if the track of the final race for the biker B1 follows the curve x square is equal to 4y where 0 less than or equal to x less than or equal to 20 root 2 and 0 less than or equal to y less than or equal to 200, then state whether the track represents a 1 1 and 1 2 function or not. See, here we have to check whether this function x square is equal to 4y 1 1 or 1 2. See, for that, say it is domain and codomain are given. Okay, and how to check 1 1 function? That is, if f of x1 is equal to f of x2, then x1 is equal to x2, right? F of x1 is equal to f of x2 implies x1 is equal to x2. Okay, now let's take it is f of x. Okay, that is x square is equal to 4y implies y is equal to x square by 4. So f of x is equal to x square by 4, right? So f of x1 is equal to x1 square by 4 and f of x2, that is equal to x2 square by 4, right? So f of x1 is equal to f of x2 implies x1 square by 4 is equal to x2 square by 4. That implies here 1 by 4 cancelled. Now we have got x1 square is equal to x2 square. That implies x1 is equal to x2 or x1 is equal to minus x2, right? If x1 is equal to x2, then f of x1 square is equal to x2 square. x1 is equal to minus x2, then x1 square is equal to x2 square, right? But it is not possible. Why? Because it is not possible for our domain. All are positive values, right? Therefore, it is not possible. So here x1 is equal to x2. Therefore, here we have got f of x1 is equal to f of x2 implies x1 is equal to x2. Okay? Hence, f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore, this function, that is x square is equal to 4y, is 1 1. Okay? Next, we have to check onto function. Okay? So, for onto function, see, we know that how to find how to check onto function. See, for that, see, we know that y is equal to x square by 4. That is 4y is equal to x square, right? That implies x is equal to plus or minus 2 root y, right? See, onto function means every elements of codomain has pre-images, right? Every elements of codomain should have pre-images. Okay. Therefore, here see x is equal to plus or minus 2 root y. So, for all the values of y, there is a corresponding values in x. Okay, there is a corresponding values of x. So, because see, you just substitute any value. Let's take this 200. Okay, see, substitute y is equal to 200. Square root of 200 means take 10, that is 10 into 2, right? So 10 root of 100 into 2, right? So square root of 100 is 10. So it will be 20 root 2, right? 2 into 10 root 2, that is 20 root 2. It is there. So here every elements of codomain has pre-images in the domain. Okay. Therefore, this function. So here we can say, for all values of x, so for all values of y, that is, y means, what are the values of y? 0 less than or equal to y less than or equal to 200. There is a corresponding x values, okay? X values in 0 less than or equal to x less than or equal to 20 root 2. Okay? Therefore, this function, this curve represents onto function. Okay. So x square is equal to 4y represents onto function. Okay. Next case study, third case study question, 13th question. Arka bought 2 cages of birds. Cage 1 contains 5 parrots and 1 mole, and cage 2 contains 6 parrots. One day, Arka forgot to lock both cages, and 2 birds flew from cage 1 to cage 2 simultaneously. Then 2 birds flew back from cage 2 to cage 1 simultaneously. Assume that all the birds have equal chances of flying. First question, when 2 birds flew from cage 1 to cage 2 and 2 birds flew back from cage 2 to cage 1, then find the probability that the all is still in cage 1. Okay. See, here we have to find the probability that all is still in cage 1. And our situation, 2 birds flew from cage 1 to cage 2 and 2 birds flew from cage 2 to cage 1. Okay. So, to find the probability of the all is still in cage 1, there are 2 situations. Okay. So, situation 1 is, see, 2 parrots, okay, 2 parrots flew from cage 1 to cage 2, okay, and 2 parrots flew from cage 2 to cage 1. Now, see, this all is still in cage 1, okay. And second situation, 1 parrot, 1 owl flew from cage 1 to cage 2, and again that is 1 parrot, 1 owl flew from cage 2 to cage 1. Now, this all is still in cage 1, right. So, there are 2 situations. So, first of all, let's find the total possibilities. Okay, means 2 birds. Okay, 2 birds flew from cage 1 to cage 2 and 2 birds flew from cage 2 to cage 1. That is total possibilities is equal to, see here in cage 1, first cage 1 there are 6 birds, right, 5 parrots and 1 owl. So here 6 birds. So out of 6 birds, 2 birds flew from cage 1 to cage 2, right. So here 6 C2 into again next, see 2 birds flew from cage 1 to cage 2, right. Therefore, there are 8 birds in cage 2 because see already 6 parrots are there, okay, and plus 2, okay. Therefore now 8 birds are in cage 2, okay. So from out of 8 birds, 2 birds flew from cage 2 to cage 1. Therefore, 8C2. So it is the total possibilities, okay. 2 birds flew from cage 1 to cage 2 and 2 birds flew from cage 2 to cage 1, okay. So what is this? 6 factorial divided by 2 factorial into 4 factorial into 8 factorial divided by 2 factorial into 6 factorial. That is equal to, here 4 factorial cancelled. So 6 into 5 divided by 2 into, here 6 factorial cancelled, 8 into 7 divided by 2. That is equal to 3 5s are 15, 15 into 4 7s are 28. That is equal to 420. Okay. Then after that, see, now we have to find the probability that the all is still in cage 1. So as I mentioned before, there are 2 situations. Okay. So one situation is 2 birds flew from the 2 parrots. Okay. 2 parrots flew from cage 1 to cage 2. Okay. And 2 parrots flew from cage 2 to cage 1. Okay. Now situation 1 is, that is probability of situation 1, okay, that is equal to, see there are see situation 1 is, first I will write situation 1, 2 parrots flew from cage 1 to cage 2 and 2 parrots flew from cage 2 to cage 1. Okay. So here probability of, that is probability is that is equal to, means it is the possibilities of situation 1, that is equal to, here how many parrots are there? 5, right? So here 2 parrots flying, that is flew from cage 1 to cage 2. Therefore, that is 5C2 into, now there are total, initially there are 6 parrots, okay, there were 6 parrots and now 2 parrots added, therefore 8 parrots. So from out of 8 parrots, 2 parrots flew from cage 2 to cage 1, right? So here also, here 8C2, okay, that is equal to 5 factorial divided by 3 factorial into 2 factorial, 8 factorial divided by 2 factorial into 6 factorial, that is equal to, here 3 factorial cancelled, so 5 into 4 divided by 2 into 7 into 8 divided by 2, that is 10 into here 28, that is 280, right? So here there are 280 possibilities for situation 1. Okay. Next, situation 2. Situation 2 is, here our all is still in cage 1, right? Our all is should be still in cage 1. Okay. Now situation 2 is 1 owl and 1 parrot flew from cage 1 to cage 2, cage 1 to cage 2, and 1 owl and 1 parrot flew from cage 2 to cage 1. Okay. Now, what are the possibilities? Okay. So here, number of possibilities is, see, 1 owl and 1 parrot, right? So 1 parrot out of 5 parrots. So here 5C1 into, see, now in cage 2 there are only 7 parrots. Okay, 7 parrots and 1 owl, right? Therefore here 1 parrot flew from cage 2 to cage 1, right? Therefore here 7C1, that is equal to 5 into 7, that is 35. Okay. Now here we have to find the probability that the owl is still in cage 1 is, that is required probability. Required probability is equal to these two cases, that is 280 plus 35 divided by, that is total possibilities. Okay, total cases 420, that is equal to, it is 315 divided by 420, that is 5 6 are 5 3s are 5 8s are 5 4s are. Okay. So here the required probability is 63 divided by 84. Three 21, 3 2s are 6, 3 8s are 24. Again 7 3s are 7 4s are. Okay, 3 by 4. 3 by 4 is the answer. Second question. When 2 birds flew from cage 1 to cage 2 and 2 birds flew back from cage 2 to cage 1 and the owl is still seen in cage 1, what is the probability that 1 parrot and the owl flew from cage 1 to cage 2? See, look at this question carefully. Here we have to find probability of 1 parrot and the owl flew from cage 1 to cage 2 and the event the owl is still seen in cage 1 has already occurred. Okay, that is, here we have to find the conditional probability. Okay, for that first of all let's take, let A be the event, 1 parrot and the owl flew from cage 1 to cage 2, cage 1 to cage 2, okay, and let B be the event. See this event, okay, all is still seen in cage 1, okay, all is still seen in cage 1, okay. Now what we have to find? We have to find, see, probability of one parrot and the owl flew from cage 1 to cage 2. It is given that the owl is still seen in cage 1. That is probability of A given B, right? That is equal to probability of A intersection B divided by probability of B. See this one. What is probability of B? See, probability of B, what is the event B? Owl is still seen in cage 1. Probability of owl, that owl is still seen in cage 1. We have already found in first question, right? So probability of B is nothing but we have got, that is 3 by 4, right? That is probability of B is probability of owl is still seen in cage 1. Okay, that we have already found. Next, what is A intersection B? A intersection B is nothing but one parrot and the one owl flew from cage 1 to cage 2, and B, see, owl is still seen in cage 1. That means that is owl and one parrot flew from, that is okay, one owl still that is flew back from cage 2 to cage 1. Okay, that is, see here, A intersection B is nothing but, see, A is this one, right? So one parrot and the owl flew from cage 1 to cage 2. Okay, and B is nothing but owl is still seen in cage 1. That means that owl flew back from cage 2 to cage 1. Okay, see, that is nothing but our situation 2. Situation 2 in first question, right? It is same as situation 2 in first question, right? Therefore, here probability of A intersection B, see, A intersection B is the event, that is one parrot and the owl flew from cage 1 to cage 2, okay, and see, B is nothing but owl is still in the seen in the cage 1. That means that owl flew back from the cage 2 to cage 1, right? So, and owl flew back, owl and one parrot, okay, flew back from cage 2 to cage 1, because it is given, see, this process is two birds flew from cage 1 to cage 2 and two birds flew back from cage 2 to cage 1. So one owl and one parrot flew back from cage 2 to cage 1. Okay. So here A intersection B is this one. So what is probability of A intersection B? Probability of A intersection B is, see, we have already found the probability of this one, right? That is this situation 2, right? That means, so probability of situation 2, okay, situation 2, we have already found in first question. Situation 2 divided by total number of, that is total possibilities, okay? Total possibilities. We have got total possibilities 420, right? So probability of situation 2 we have got in first question, that is 35. So that is divided by 420. Okay, that is equal to 7 divided by 84. Okay. Now probability of B. What is probability of B? That is probability of all still seen in cage 1, that we have already found in first question, that is 3 by 4. Okay. Now probability of A given B is equal to probability of A intersection B divided by probability of B, that is equal to 7 divided by 84 divided by 3 by 4. That is equal to 7 by 84 into 4 by 3. 4 ones are 4, 2, 1. So here 7, 3, 7. That is 1 by 9. Okay, so required probability is equal to 1 by 9.